Hello there, and welcome. Tonight I want to take you somewhere special, somewhere that exists between the ticking of clocks and the spaces between heartbeats, a place where time itself becomes soft and malleable, like warm clay in gentle hands. I want to take you on a journey not through space, though we'll travel there too, but through the very fabric of time itself, through questions that have haunted humanity since we first looked up at the stars and wondered about our place in this vast, mysterious cosmos. Tonight, we're going to explore a question that might sound impossible at first, perhaps even absurd, but I promise you, as we drift together through these thoughts, you might find yourself wondering if impossibility is just another word for something we haven't understood yet. What if the past still existed somewhere you could visit? What if every moment that has ever been, every sunset that has ever painted the sky, every first breath and last goodbye, what if all of it still exists somewhere, perfectly preserved like flowers pressed between the pages of an infinite book? It's a question that sounds impossible at first, doesn't it? Our everyday experience tells us that the past is gone, swept away like footprints on a beach, erased by the relentless tide of now. But the universe is rarely simple, and perhaps, just perhaps, it's not as linear as it seems. Perhaps time isn't the straight arrow we imagine it to be, flying from past through present into future. Perhaps it's something else entirely, something more beautiful, more mysterious, more accessible than we've ever dared to imagine. Before we go any further on this journey together, I'd love to know where you're listening from tonight. Are you tucked into bed in a city where lights twinkle like earthbound stars? Are you in a quiet suburban room where the only sound is the gentle hum of night? Or perhaps you're somewhere rural, where the darkness is deep and the stars above are bright and countless. Whatever corner of our beautiful planet you're in, whatever time zone cradles you right now, know that you're part of a quiet circle of night watchers, fellow travellers who choose to spend these precious hours not in frantic activity but in gentle contemplation. If you're finding comfort in these words, if this journey speaks to something deep within you, consider subscribing to join our growing community of cosmic wanderers. Like this video if it brings you peace, and share it with someone who might need a gentle escape into wonder. But most importantly, make yourself comfortable, because we have a long, beautiful journey ahead of us tonight. As you settle in, perhaps adjusting your pillow, pulling your blanket a little closer, take a moment to notice your breathing. Each inhale brings oxygen that was breathed by dinosaurs, by ancient forests, by the first creatures that crawled from primordial seas. Each exhale releases atoms that will one day be part of new life, new stories, new moments in time. You see, even in this simple act of breathing, you're already participating in a kind of time travel, already connected to both the deep past and the distant future through the simple exchange of air. Your body, this miraculous collection of atoms and energy that you call yourself, is already a time machine of sorts, carrying within it the history of the universe and the seeds of futures yet to be born. Let's begin by considering the scale of time, starting with something familiar, something human. A single heartbeat takes about 1 second. In that second, light travels 282 miles, circling the Earth more than 7 times. In that same second, the Earth itself travels about 18 miles through space in its orbit around the Sun, while our entire solar system hurtles through the galaxy at speeds that would make your mind spin if you tried to truly comprehend them. 1 second, 1 heartbeat, and already we're dealing with distances and velocities that challenge our everyday understanding of reality. Now stretch that out to a minute. 60 heartbeats, 60 moments of now becoming then. In a minute you might read a page of a book, have a brief conversation, make a cup of tea. It seems like such a small unit of time, doesn't it? And yet in that minute the universe has expanded by millions of miles. Countless stars have been born and died in distant galaxies, and waves of gravitational energy from colliding black holes billions of years ago have passed through your body without you feeling a thing. An hour contains 60 of these minutes, 3/600 seconds, 3/600 heartbeats if you're at rest. In an hour you might watch the sunset paint the sky in shades of gold and crimson. You might have a meal with someone you love. You might drift into a dream. In an hour, the Earth rotates 15 degrees on its axis, carrying you through space at 1,000 miles per hour if you're at the equator, though you feel nothing but stillness. In that same hour, our planet has travelled more than 67,000 miles, through space in its journey around the sun. These numbers aren't meant to overwhelm you, but to gently expand your sense of what's happening in each moment, to help you feel the vastness of motion and change that underlies even our quietest experiences of time. A day, that most natural of human time units, marked by one rotation of our planet, contains 86,400 seconds, 86,400 potential moments of awareness, of choice, of experience. In a single day, you cycle through waking and sleeping, through hunger and satisfaction, through all the small rituals that make up a life. You might not remember most of these moments. They slip away like water through fingers. But what if they don't disappear? What if each of those 86,400 seconds is preserved somewhere, like photographs in an album you can't quite reach? In a day, the Earth travels 1.6 million miles through space. In a day, light from the sun could travel to Earth and back more than 400 times. In a day, your body replaces millions of cells, each one carrying the same DNA that has been copied and passed down through billions of years of evolution, each one a living link to the deep past. A year, that grand cycle of seasons, contains 365 of these days, 31,136,000 seconds if we're not in a leap year. A year might contain a few moments you'll remember forever. First kisses, last goodbyes, moments of triumph or loss that seem to burn themselves into the very fabric of your being. But it also contains millions of moments you'll forget. Ordinary Tuesday afternoons, unremarkable meals, the 1,000th time you brushed your teeth. Where do these forgotten moments go? Do they simply cease to exist because we don't remember them? Or might they persist somewhere, waiting patiently in the vast archives of time? In a year, our planet completes one full orbit around the sun, travelling 584 million miles through space. In a year, the light from nearby stars has time to travel trillions of miles, carrying information about what those stars were like 1 year ago, because even at the incredible speed of light, information takes time to travel through the vastness of space. Now let's stretch our perception beyond human scales. A human lifetime, let's say 80 years to pick a round number, contains about 2.5 billion seconds. That might sound like a lot, and it is from our perspective enough seconds to fall in love multiple times, to watch children grow, to accumulate wisdom and memories and regrets. But from the perspective of the universe, a human lifetime is barely a whisper. If the history of the universe were compressed into a single year, with the Big Bang occurring at midnight on January 1st, human civilization wouldn't appear until the last few seconds before midnight on December 31st. Your entire lifetime, those 2.5 billion seconds that contain everything you've ever experienced or will experience, would be less than the blink of an eye in this cosmic year. Consider the age of our species. Homo sapiens has existed for roughly 300,000 years. That's about 10 trillion seconds of human experience, of our ancestors looking up at the same stars we see, wondering the same questions we wonder, feeling the same hopes and fears that move through us tonight. Every human who has ever lived, from the first members of our species emerging in Africa to you lying here, listening to these words, every single one has experienced time in much the same way we do, as a flowing river that carries us from birth to death, from morning to night, from moment to moment. And yet, what if this flowing river is an illusion? What if all those trillion seconds of human experience still exist somewhere, not lost but simply elsewhere? The Earth itself is about 4.5 billion years old. That's roughly 142 quadrillion seconds, a number so large that our minds can't really grasp it. In those billions of years, our planet has seen incredible transformations. It has been a molten ball of rock, a frozen snowball, a world of toxic gases, and finally, miraculously, a living world teeming with an incredible diversity of life. Mountains have risen from sea floors and been worn down to nothing. Entire continents have drifted across the globe, colliding and separating like slow-motion dancers. Species beyond counting have evolved, thrived, and gone extinct, leaving only fossil traces of their existence. The dinosaurs ruled the Earth for 165 million years, far longer than mammals have been dominant, and now they exist only as bones in rock and birds in the sky. But what if, in some sense we don't yet understand, those ancient worlds still exist? What if the Earth of the dinosaurs, the Earth of the first living cells, the Earth of tomorrow, What if they're all equally real, equally present in the grand structure of space-time? Our Sun, the star that makes life on Earth possible, is about 4.6 billion years old and has perhaps another 5 billion years before it exhausts its nuclear fuel and swells into a red giant. The Sun has been shining for about 145 quadrillion seconds, and in every one of those seconds, it has been converting 600 million tons of hydrogen into helium, releasing energy that travels 93 million miles to warm our planet and power the vast majority of life on Earth. Every second, the Sun releases more energy than humanity has used in its entire history. This has been happening continuously for billions of years, a steady cosmic heartbeat that marks time on scales we can barely imagine. The sunlight that warms your face today left the Sun's surface about 8 minutes and 20 seconds ago, but the energy in that light was generated in the Sun's core anywhere from 10,000 to 170,000 years ago, taking that long to work its way from the centre to the surface. Even sunlight carries the past within it, a warm reminder that the past and present are more intimately connected than we might think. Our galaxy, the Milky Way, is approximately 13.6 billion years old, nearly as old as the universe itself. It contains between 200 and 400 billion stars, each one with its own story, its own cycle of birth and death, its own collection of seconds ticking away in the vast darkness. If we could travel at the speed of light, it would take us 100,000 years to cross from one edge of our galaxy to the other. The Milky Way has been spinning for about 430 quadrillion seconds, a vast spiral of stars and gas and dark matter, rotating once every 225 million years. Our Sun and solar system have completed perhaps 20 full orbits around the galactic centre since they formed. Each orbit is sometimes called a cosmic year, and in each cosmic year entire species rise and fall on Earth, continents reshape themselves, and the stars themselves slowly change their positions in our night sky. And then there's the universe itself, born 13.8 billion years ago, in an event we call the Big Bang, though it was neither big in the conventional sense nor a bang as we understand explosions. It was the beginning of space and time themselves, at least as far as we can tell from our current vantage point. The universe has existed for about 435 quadrillion seconds, and in every one of those seconds, it has been expanding, cooling, evolving, complexifying. In the first second after the Big Bang, more happened than has happened in all the billions of years since. The fundamental forces separated, the first particles formed, the seeds of everything we see today were planted in that first incredible second. And here's a thought that might keep you pondering as you drift towards sleep. If time began with the Big Bang, what does it mean to ask what came before? Is it possible that our entire universe, all 435 quadrillion seconds of it, exists as a single, timeless structure when viewed from outside our dimensional limitations? As we contemplate these vast scales of time, from seconds to billions of years, it's natural to feel small, perhaps even insignificant. But I want to suggest a different perspective. Yes, you're small compared to the universe, and yes, your lifetime is brief compared to cosmic time, but you're also the universe becoming aware of itself. Through your eyes, the cosmos sees itself. Through your thoughts, it contemplates its own existence. You're not separate from the vast scales of time we've been discussing. You're an integral part of them. Every atom in your body, except for hydrogen, was forged in the heart of a dying star billions of years ago. You are literally made of cosmic history, a collection of ancient stardust that has temporarily arranged itself into a pattern capable of wondering about time and existence. This brings us back to our central question, the one that will guide us through this night's journey. What if the past still exists somewhere you could visit? Not metaphorically, not just in memory or imagination, but actually, physically, really. What if every moment we've been discussing, from the first second after the Big Bang to this very instant as you listen to these words, what if they all exist simultaneously in some grand, four-dimensional structure we call spacetime? It's an idea that emerges from our best theories of physics, from Einstein's relativity and the strange implications of how time and space are interwoven. It's an idea that challenges everything our intuition tells us about time, but then again, the universe has never been particularly concerned with conforming to human intuition. Think about it this way. When you look at a mountain, you can see its entire shape all at once, from base to peak, the bottom of the mountain doesn't cease to exist just because you're looking at the top. The whole mountain exists simultaneously, even though you might only be able to stand on one part of it at a time. What if time is similar? What if your entire life, from birth to death, exists like a mountain in four-dimensional spacetime, and what we call the present is just the particular point where your consciousness happens to be standing right now? This isn't mysticism or fantasy. This is a serious idea discussed by physicists and philosophers, though they're far from reaching consensus about what it means or whether it's true. As we prepare to dive deeper into this mystery, to explore the evidence and implications of this possibility, I want to acknowledge that this might all sound a bit overwhelming or even impossible. That's okay. We're not here to convince you of anything or to claim we have answers to questions that have puzzled humanity for millennia. We're here to wonder together, to explore possibilities, to let our minds wander through ideas that might just shift how we think about our place in the cosmos. And if, along the way, these gentle contemplations help you drift into peaceful sleep, well, that's a beautiful outcome too. After all, what is sleep but a kind of time travel, a jump from night to morning, from today to tomorrow, with dreams in between that might touch on any moment from past or future? Consider how strange and wonderful it is that we can even ask these questions. A collection of atoms that originated in the Big Bang and were processed through generations of stars has arranged itself into a pattern complex enough to wonder about its own origins and destiny. You, lying there in the darkness, are the universe's way of looking back at itself across billions of years and asking, what am I? How did I get here? Where am I going? These aren't just abstract philosophical questions. They're the universe questioning itself through you. And perhaps, just perhaps, the answer involves a cosmos where every moment is eternal, where the past is not lost but simply elsewhere, where time is not a river but an ocean, and we are not carried along by its current but floating in a tiny bubble of now on its vast surface. The night is deep around us now, and we're just beginning our journey. As you continue to breathe, to exist, to move through time at the steady rate of 1 second per second, remember that you're not just passing through these moments. You're creating them, experiencing them, and perhaps, in some way we don't yet understand, preserving them forever in the grand tapestry of space-time. Every breath you take adds another moment to the collection, another instant that might, somewhere, somehow, always exist. It's a thought both humbling and elevating, a reminder that we are small but not insignificant, brief but perhaps eternal, limited in our perception but unlimited in our capacity to wonder. In the quiet of this night, with the universe wheeling overhead whether you can see it or not, with time flowing through and around you like an invisible river, you are part of something magnificent and mysterious. You are a conscious observer in a cosmos that might preserve every observation forever. You are a traveller in time, moving always forward at the pace of existence itself, yet connected through memory and matter to everything that has come before. And as we continue this journey together, exploring how light carries the past, how space-time might contain all moments, how the universe itself might be a kind of vast memory bank, remember that the greatest mysteries are not problems to be solved, but invitations to wonder. The clock beside your bed, if you have one, is marking seconds that will never come again, or will they? The earth beneath you is spinning through space, carrying you into tomorrow at 1,000 miles an hour, though you feel perfectly still. The stars above, whether hidden by ceiling and clouds or visible in all their glory, are sending you light from the past, messages from years or centuries or millennia ago, depending on their distance. You are surrounded by the past, made of the past, moving into a future that might already exist, waiting patiently for you to arrive. It's enough to make your head spin if you think about it too hard, or enough to fill you with a deep sense of peace if you simply let it wash over you like a gentle wave. We float now above a timeline that stretches far beyond human memory, like a shoreline that vanishes into mist on both sides, extending into distances our minds struggle to comprehend. Imagine standing on a beach at night, listening to waves that have been breaking on shores for billions of years, each wave a moment, each grain of sand a second, the entire beach a vast accumulation of time that dwarfs our individual existence. Yet here you are, one small figure on this cosmic beach, aware, conscious, capable of contemplating the very enormity that surrounds you. You are like a single grain of sand that has somehow learned to contemplate the beach, the ocean, and its own place among countless other grains. Let me take you on a journey through scales of time that will gently stretch your perception, not to make you feel small, but to help you understand the magnificent context in which your life unfolds. We'll start with the familiar and gradually expand our view until we're contemplating ages so vast that numbers become almost meaningless. Yet within these incomprehensible spans, patterns emerge that connect you to everything that has ever been. Think of this as slowly adjusting the lens of a telescope, each turn revealing more of the cosmic landscape, each new view adding depth to our understanding of where and when we are. A single day in your life contains roughly 86,400 seconds, as we mentioned before, but let's think about what happens in nature during one rotation of our Earth. In a single day, bamboo can grow up to 35 inches, visibly reaching toward the sky. Mayflies complete their entire adult lives, emerging, mating, and dying in what seems like a brief moment to us but is a complete existence to them. Arctic terns, those remarkable birds, fly about, 5 and 20 miles in their daily journey during migration, part of an annual circuit that takes them from Arctic to Antarctic and back, the longest migration in the animal kingdom. In one day, your heart beats about 100,000 times, pumping blood through 60,000 miles of blood vessels, a network that could wrap around the Earth twice. Each of these heartbeats is a moment, and now that becomes then, yet the rhythm continues, connecting past to future through the present pulse of life. Now let's expand to a year, 365 days spinning around our star. In a year, continents drift about 2.5 centimeters, roughly the rate your fingernails grow. It seems impossibly slow, doesn't it? Yet given enough years, this gentle drift has rearranged the entire face of our planet multiple times. In a year, a tree adds another ring to its trunk, a physical record of time that we can count centuries later. Some trees alive today have more than 5,000 rings, meaning they've been quietly recording time since before the pyramids were built. In a year, mountains erode by fractions of millimeters, worn down by wind and rain and ice, in a process so slow we can't see it happening, yet so persistent that entire mountain ranges have been reduced to plains and raised up again multiple times in Earth's history. Consider a human lifetime, those roughly 80 years we mentioned earlier. In one human lifetime, Halley's Comet returns once, maybe twice if you're fortunate. A cosmic visitor that connects generations through shared wonder. Your grandparents might have seen it, you might see it, your grandchildren might see it, all looking at the same object but from different points in its eternal journey around the sun. In a lifetime, the stars in the night sky shift slightly in their positions, a phenomenon called proper motion, too slow for us to notice year to year, but enough that the constellations our ancestors saw were subtly different from the ones we see today. In a lifetime, radioactive carbon-14 atoms in your body decay by about 1%, a slow atomic clock that scientists can use to date organic materials thousands of years after death. Now let's step beyond human experience into what we call historical time. The pyramids of Giza have stood for about 4,500 years, roughly 60 human lifetimes. In that time, they've watched the rise and fall of empires, the birth of religions, the transformation of the desert around them. They've been the tallest human-made structures for most of their existence, only surpassed in height in the last few centuries. Yet from the pyramids' perspective, if stones could have perspective, human civilizations flicker by like shadows, brief patterns of activity that emerge and fade while the pyramids endure. The stones remember, in their way, carrying the touch of ancient hands, the weight of centuries, the slow erosion of wind-blown sand. They are monuments not just to human achievement, but to the persistence of matter through time. Writing has existed for about 5,000 years, a technology that allows us to send messages through time, to communicate with people who won't be born for centuries. When you read ancient texts, you're receiving thoughts from minds that ceased to function millennia ago, yet their ideas persist, encoded in symbols that bridge the gap between their now and yours. Every book is a time capsule, every word a fossilized thought, every library a collection of moments preserved across centuries. The Epic of Gilgamesh, one of our oldest stories, has been telling the same tale for 4,000 years, its themes of friendship, mortality, and the search for meaning as relevant today as they were in ancient Mesopotamia. Stories, it seems, are one way humans have learned to make the past persist into the present. Agriculture has been practiced for roughly 12,000 years, transforming humanity from nomadic hunters and gatherers into settled civilization builders. In that time, we've bred wolves into dogs, wild grasses into wheat and corn, wild aurochs into docile cattle. Each generation of farmers selected and planted seeds from the best plants, slowly sculpting species to our needs, encoding human intention into the very DNA of our food. Every grain of wheat you eat carries 12,000 years of human choice within its genes, a living connection to countless farmers who saved seeds and planted fields long before history was written. The landscape itself has been transformed, forests cleared, fields ploughed, the very soil enriched or depleted by millennia of cultivation. The Earth remembers this transformation in its changed ecosystems, in the distribution of species, in the very chemistry of its atmosphere. The last ice age ended about 11,700 years ago, marking the beginning of our current geological epoch, the Holocene. As the great ice sheets retreated, they carved the landscape we know today, leaving behind the Great Lakes, fjords, and countless valleys. The weight of ice had pressed the land down, and even now, thousands of years later, some parts of the Earth are still slowly rising in a process called post-glacial rebound, the planet itself still responding to the memory of that ancient weight. In Scandinavia, land rises about 1 centimetre per year, beaches becoming meadows, harbours becoming inland towns, the ghost of ice still shaping the present. The Earth, it seems, has a long memory, carrying the impressions of the past into the future, through slow, patient processes we're only beginning to understand. Modern humans, Homo sapiens, have existed for approximately 300,000 years. In that time, we've survived ice ages and warm periods, massive volcanic eruptions and asteroid impacts, plagues and famines. For most of that time, perhaps 290,000 years, we lived in small bands, hunting and gathering, telling stories around fires, painting on cave walls. All of recorded history, everything we call civilization, represents less than 2% of our species' existence. Yet in that brief time, we've transformed, from cave painters to space explorers, from storytellers around fires to creators of global communication networks. But our bodies and brains remain largely unchanged from those ancient ancestors. When you feel fear, love, wonder, or curiosity, you're experiencing emotions that have been part of humanity for thousands of generations. Your capacity for awe as you look at the stars is the same capacity that moved our ancestors to create the first calendars, the first myths, the first attempts to understand our place in the cosmos. The genus Homo, the group of species that includes modern humans and our extinct relatives, has existed for about 2.8 million years. In that time, many human species have come and gone. Homo habilis, the first tool users, Homo erectus, the first to control fire and leave Africa, Homo neanderthalensis, our cousins who created art and buried their dead with flowers. Each species had its own way of being human, its own cultures and capabilities, its own experience of time and existence. They all looked at the same sun and moon we see, felt the same rain, experienced the same fundamental reality, yet they're all gone now except for the traces they left in stone tools, fossils, and in some cases, in our own DNA. We carry within us genetic memories of encounters with other human species, matings that occurred tens of thousands of years ago, yet still influence who we are today. Mammals have dominated the Earth for about 66 million years, since the extinction of the non-avian dinosaurs. In that time, the mammalian lineage has produced creatures as diverse as blue whales, the largest animals ever known, and bumblebee bats which weigh less than a penny. From a common ancestor that was probably a small nocturnal insect-eating creature, mammals have radiated into every environment on Earth, from the deepest oceans to the highest mountains, from scorching deserts to frozen tundra. The story of mammalian evolution is written in bones and genes, in the similarity of our limb structures and the shared chemistry of our milk. When a human mother nurses her child, she's performing an act that connects her to 66 million years of mammalian history, a behaviour that has persisted through countless species and environments, a thread of continuity through deep time. The dinosaurs ruled the Earth for approximately 165 million years, far longer than mammals have been dominant. They evolved into an incredible diversity of forms, from tiny feathered species no bigger than chickens to massive long-necked sauropods that were the largest land animals ever to exist. They developed complex social behaviours, some caring for their young, others hunting in packs. They survived massive changes in climate and geography, adapting and diversifying across millions of generations. Then, in what seems like an instant from a geological perspective, they were gone, wiped out by an asteroid impact that changed the world in a matter of hours. Yet they're not entirely gone. Birds are living dinosaurs, the only lineage to survive the extinction. Every sparrow, every eagle, every penguin is a dinosaur, carrying forward a story that began over 200 million years ago. When you hear birds singing at dawn, you're listening to the descendants of creatures that walked with Tyrannosaurus rex. Complex multicellular life has existed for about 600 million years, beginning with what we call the Cambrian explosion, though it was less an explosion and more a relatively rapid diversification that took place over millions of years. Before this, for billions of years, life consisted only of single-celled organisms, bacteria and archaea living in seas and sediments, slowly transforming the planet's chemistry. The emergence of complex life, creatures with specialized cells working together, was one of the major transitions in Earth's history. In the Cambrian seas, nature experimented with body plans, creating creatures so strange that when fossils of them were first discovered, scientists couldn't figure out which end was up or how they lived. Many of these experiments failed, entire lineages going extinct, but some survived and became the ancestors of every animal alive today, including you. Life itself has existed on Earth for at least 3.5 billion years, possibly longer. For most of that time, the planet would have been unrecognizable to us, with no oxygen in the atmosphere, no plants on land, no animals in the seas. The early Earth was a world of bacteria and archaea, microscopic organisms that nonetheless transformed the planet in profound ways. They invented photosynthesis, filling the atmosphere with oxygen in what was actually a massive pollution event that killed off many early life forms, but paved the way for oxygen-breathing organisms like us. They developed all the basic biochemical processes that life still uses today: DNA replication, protein synthesis, cellular respiration. Every living thing on Earth, from the smallest bacterium to the largest whale, uses essentially the same genetic code, the same basic chemistry, a unity that speaks to our common origin in the deep past. The Earth formed about 4.5 billion years ago from the gravitational collapse of dust and gas in the early solar system. For its first few 100 million years, our planet was a hellish place, bombarded by asteroids and comets, its surface molten, its atmosphere toxic. Gradually it cooled and solidified, water condensed from the atmosphere or was delivered by comets, and the first oceans formed. The Moon, our constant companion, was probably formed when a Mars-sized object collided with the early Earth, throwing debris into orbit that eventually coalesced into our satellite. That collision, violent as it was, may have been crucial for life's eventual emergence, giving Earth its tilted axis that creates seasons and its large moon that stabilizes that tilt. Every time you see the moon in the night sky, you're looking at a reminder of cosmic violence that helped make our living world possible. Our solar system, including the Sun and all its planets, formed about 4.6 billion years ago from a nebula, a vast cloud of gas and dust that collapsed under its own gravity. This collapse was probably triggered by the shockwave from a nearby supernova, the death of an ancient star providing the push that would eventually lead to our birth. As the nebula collapsed, it began to spin, flattening into a disk. Most of the material fell into the center, forming the Sun, while the remaining dust and gas in the disk slowly accumulated into planets. The inner planets, including Earth, formed from rocky material that could withstand the Sun's heat, while the outer planets formed from ice and gas in the cooler regions of the disk. This process of planetary formation took millions of years, countless collisions of dust grains building to pebbles, pebbles to boulders, boulders to planetesimals, planetesimals to planets. The Milky Way galaxy, our cosmic home, formed about 13.6 billion years ago, shortly after the universe itself began, It started as a relatively small collection of stars and gas and has grown through cosmic time by consuming smaller galaxies, a process that continues today. The Milky Way has eaten dozens of smaller galaxies over its lifetime, incorporating their stars and gas into its own structure. Right now, it's in the process of absorbing several small satellite galaxies, and in about 4.5 billion years, it will collide and merge with the Andromeda Galaxy, our nearest large galactic neighbour. These galactic collisions sound violent, and they are on a cosmic scale, but the distances between stars are so vast that few, if any, stars actually collide. Instead, the galaxies pass through each other, their gravity distorting each other's shapes, throwing stars into new orbits, triggering new waves of star formation. And finally, we come to the universe itself, 13.8 billion years old, born in an event we struggle to understand despite our best theories and observations. The Big Bang wasn't an explosion in space. It was the beginning of space itself, and of time as we understand it. In the first fraction of a second, the universe underwent inflation, expanding faster than the speed of light, growing from subatomic size to something approaching its current scale. Then it slowed, cooled, and began the long process of forming the structures we see today. First came elementary particles, then atoms, then the first stars, then galaxies, then second and third generation stars with planets, and eventually, on at least one small rocky world, life and consciousness, and the ability to contemplate it all. When we talk about these vast scales of time, billions of years, it's natural for the numbers to become meaningless, too large to truly grasp. So let's try a thought experiment. Imagine the entire history of the universe compressed into a single year, with the Big Bang occurring at midnight on January 1st. On this scale, the Milky Way doesn't form until March, the solar system doesn't form until September. Life on Earth doesn't appear until sometime in September or October. Complex multicellular life doesn't evolve until mid-November. The dinosaurs don't appear until Christmas and go extinct on December 30th. All of human history, from the first Homo sapiens to now, takes place in the last 14 seconds before midnight on December 31st. Recorded human history is the last second. Your entire life is a fraction of that last second. Yet here's the remarkable thing. In that tiniest fraction of cosmic time, you have developed the capacity to comprehend the whole sweep of it. You can hold in your mind the concept of 13.8 billion years, even if you can't truly feel its vastness. You can trace the connections from the Big Bang to the formation of atoms, to the birth of stars, to the creation of heavy elements, to the formation of planets, to the emergence of life, to the evolution of consciousness, to this very moment as you lie in the darkness, thinking about time. You are the universe's way of knowing itself, of remembering its own history, of contemplating its own existence. Every atom in your body, except hydrogen, was forged in the heart of a star that died before our sun was born. The carbon in your DNA, the iron in your blood, the calcium in your bones, all of it is stellar ash, the remnants of cosmic furnaces that burned billions of years ago. When we think about the past on these scales, it becomes clear that the past isn't really past at all, not in any absolute sense. It lives on in the present through countless connections and continuities. The light from distant galaxies brings us images from billions of years ago. The cosmic microwave background radiation, which we'll explore more later, is the echo of the Big Bang itself, still reverberating through the universe 13.8 billion years later. The rocks beneath your feet contain radioactive elements still decaying from their formation in ancient supernovae. The water you drink has been cycling through clouds and rain and rivers and oceans for billions of years. The very atoms that make up your body have been part of rocks and air and other living things countless times over. In this view, you're not separate from the vast scales of time we've been discussing. You are an expression of them, a temporary arrangement of ancient matter and energy that has briefly organized itself into a pattern capable of consciousness. You are a way for the universe to experience itself subjectively, to feel and think and wonder about its own nature. The vast oceans of time don't diminish you. They're the context that makes your existence possible and meaningful. Without billions of years of cosmic evolution, there would be no atoms to form your body. Without billions of years of stellar nucleosynthesis, there would be no complex chemistry. Without billions of years of biological evolution, there would be no brain capable of contemplating its own existence. And this brings us back to our central question, approaching it from a new angle. If you are made of the past, if the past lives on in you and everything around you, then perhaps the distinction between past and present is not as clear as we usually think. Perhaps time is not a river that flows and is gone, but an ocean where every drop of water, every moment continues to exist, even after the waves have moved on. Perhaps the universe remembers everything, not in some mystical sense, but in the very fabric of space-time, in the patterns of matter and energy, in the information encoded in every particle and wave. Think about memory for a moment. Not cosmic memory, but your own personal memory. When you remember something from your childhood, what exactly is happening? Neurons in your brain are firing in patterns that somehow recreate the experience, not perfectly, but close enough that you can feel again what you felt then, see again what you saw. The past, in a very real sense, is being recreated in the present through the physical processes of your brain. But what if the universe itself has a kind of memory? What if the structure of space-time somehow contains or preserves every moment that has ever occurred? Not in the way a brain stores memories, through patterns of neural connections, but in some deeper way we're only beginning to glimpse through our physics and mathematics. This is not just philosophical speculation. Modern physics, particularly Einstein's theory of relativity, suggests that time might not work the way our everyday experience tells us it does. In relativity, space and time are not separate things but aspects of a single, four-dimensional continuum called space-time. Events don't happen in space and then disappear in time. They exist as permanent features of the space-time landscape. Your birth, your first day of school, this very moment as you listen to these words, they might all exist simultaneously in the grand structure of space-time, like different locations on a vast four-dimensional map. In the stillness of the night sky, every star you see is already a memory, gently arriving at your eyes after a journey that might have taken years, centuries, or millennia to complete. This isn't metaphor or poetry, though it is poetic. This is the simple, beautiful truth of how light works in our universe. When you look up at the stars, you're not seeing them as they are right now, in this moment. You're seeing them as they were when their light began its journey toward Earth, carrying across the vast darkness a message from the past, a gentle whisper that says, "This is how I was." Every photon that enters your eye from a distant star is a tiny time capsule, a packet of information preserved perfectly across the void, delivering news from another time as fresh as if it had just been sent, because for the photon itself, no time has passed at all. Let's begin with something close, something familiar. The moon hanging in the night sky, our nearest celestial neighbour. The moon is about 230 900 miles away from Earth on average, though this distance varies as it follows its elliptical orbit. Light travels at 186,282 miles per second, that cosmic speed limit that nothing with mass can exceed. When you do the simple arithmetic, you find that moonlight takes about 1.28 seconds to reach Earth. So when you look at the moon, you're seeing it as it was just over a second ago. If something were to happen to the moon right now, if it were to suddenly change colour or disappear entirely, though of course it won't, you wouldn't know for 1.28 seconds. You're always looking at the moon's recent past and never its present. This might seem like a trivial delay, barely worth mentioning, but think about what this means. There is no such thing as seeing something right now if it's any distance away from you at all. Even when you look at your hand held at arm's length, you're seeing it as it was a few nanoseconds ago, the time it took light to travel from your hand to your eye. When you look across a room at someone you love, you're seeing them as they were a few nanoseconds in the past. We never see the present moment of anything except perhaps our own thoughts, and even those involve electrical signals travelling through neurons at speeds much slower than light. We live in a universe where information takes time to travel, where the present is always local, always personal, never universal. Now let's look further out to our sun, that blazing star that makes life on Earth possible. The sun is about 93 million miles away, what astronomers call one astronomical unit. At the speed of light, solar radiation takes approximately 8 minutes and 20 seconds to reach Earth. When you feel sunlight warming your face, you're feeling energy that left the sun's surface over 8 minutes ago. If the sun were to suddenly stop shining, which it won't for billions of years, we wouldn't know for 8 minutes and 20 seconds. we would continue to see the sun in the sky, continue to feel its warmth, completely unaware that our star had gone dark. For those 8 minutes and 20 seconds, we would be living in a reality that no longer existed, sustained by light from a past that had already ended. But here's where it gets even more interesting. The light that takes 8 minutes and 20 seconds to travel from the sun's surface to Earth took much, much longer to get from the sun's core to its surface. Deep in the sun's core, where temperatures reach 15 million degrees Celsius and pressures are 250 billion times greater than Earth's atmosphere, hydrogen nuclei are fusing into helium, releasing tremendous amounts of energy. This energy, initially in the form of gamma rays, begins what scientists call a random walk toward the surface. The sun is so dense that photons can't travel in straight lines. They're constantly being absorbed and re-emitted by particles, changing direction with each interaction, slowly diffusing outward like heat through a thick blanket. This random walk from core to surface takes an incredibly long time. Estimates vary, but it's somewhere between 10,000 and 170,000 years, with many scientists settling on around 100,000 years as a reasonable average. Think about what this means. The warmth you feel on your skin right now began its journey when humans were first migrating out of Africa, when Neanderthals still walked the earth, when mammoths and saber-toothed cats roamed the continents. The sunlight of today carries energy from the deep past, 100,000 years of slow percolation through stellar plasma before 8 minutes of swift flight through the vacuum of space. Let's venture further out into our solar system. Jupiter, the giant of our planetary family, orbits at an average distance of about 484 million miles from the Sun. When Jupiter is closest to Earth, a configuration called opposition, it's about 365 million miles away. Light from Jupiter, which is actually reflected sunlight, takes about 33 minutes to reach us at this closest approach. When Jupiter is on the far side of the Sun from Earth, that delay stretches to about 49 minutes. So when astronomers observe Jupiter through their telescopes, they're seeing events that happened somewhere between half an hour and an hour ago. The Great Red Spot, that enormous storm that has been raging for at least 350 years, appears to us not as it is but as it was when the light we're seeing left its turbulent clouds. Saturn, with its magnificent rings, orbits even further out, and the light delay stretches to over an hour. When the Cassini spacecraft sent its final images as it plunged into Saturn's atmosphere in September 2017, those images took 83 minutes to reach Earth. The scientists and engineers watching their screens saw Cassini's destruction 83 minutes after it had actually occurred. For an hour and 23 minutes after Cassini had been vaporized in Saturn's clouds, its final signals were still traveling toward Earth, carrying its last observations across the void. In a very real sense, Cassini lived on for those 83 minutes in the light it had sent, still communicating, still sharing data, even though the spacecraft itself was already gone. Now let's leave our solar system entirely and look at the stars. The nearest star to our Sun is Proxima Centauri, a small red dwarf star about 4.24 light-years away. A light-year, despite its name, is a measure of distance, not time. It's the distance light travels in 1 year, about 5.88 trillion miles. When we see Proxima Centauri in the sky, we're seeing it as it was 4.24 years ago. If you're 30 years old, the light entering your eyes from Proxima Centauri left that star when you were 25. You're looking at a star that exists in what you think of as your past, seeing it in a state that no longer exists, yet the image is real, the photons are real, the information they carry is real. Sirius, the brightest star in our night sky, is about 8.6 light-years away. The light you see from Sirius tonight left that star when the world was a different place, when different people were in power, when some of the people you know hadn't been born yet. Vega, one of the brightest stars in the summer sky, is 25 light-years away. Its light left when the World Wide Web was young, when most people had never sent an email, when smartphones were science fiction. Polaris, the North Star that has guided navigators for centuries, is about 433 light-years away. The light you see from Polaris tonight began its journey during the Renaissance, when Shakespeare was writing his plays, when Galileo was first pointing his telescope at the heavens. The Pleiades, that beautiful cluster of stars also known as the Seven Sisters, is about 444 light-years away. When you see their delicate blue light, you're receiving photons that left those stars before your great grandparents were born. Betelgeuse, the red giant star that marks Orion's shoulder, is about 650 light-years away and nearing the end of its life. Astronomers expect it to explode as a supernova sometime in the next 100,000 years, but here's the thing. For all we know, it might have already exploded. It could have exploded 500 years ago, and we wouldn't know yet. We would still see Betelgeuse shining in Orion's shoulder for another 150 years before the light from its destruction reached us. The Orion Nebula, that fuzzy patch in Orion's sword visible even to the naked eye, is about 1,144 light-years away. It's a stellar nursery, a place where new stars are being born from collapsing clouds of gas and dust. But the births we see happening there actually happened during the early Middle Ages. The stars being born in the Orion Nebula right now, in our present, won't be visible to Earth for another 1,244 years. Our descendants in the year 3368 will see the Orion Nebula as it is today, while we see it as it was in the year 680. As we look deeper into space, we look deeper into time. The centre of our Milky Way galaxy is about 26,000 light-years away. When we observe the supermassive black hole at our galaxy's heart, we're seeing it as it was when Earth was in the grip of the last ice age, when humans were painting elaborate art on cave walls, when mammoths and giant ground sloths still roamed the continents. The edge of our galaxy's disk is about 50,000 light-years from the centre, so we see the far edge of our own galaxy as it was when Homo sapiens was first developing complex language and symbolic thought. The Andromeda Galaxy, the nearest large galaxy to our own, and the most distant object visible to the naked eye under dark skies, is about 2.5 million light-years away. When you see that faint fuzzy patch in the constellation Andromeda, you're seeing light that left when our ancestors were just beginning to walk, upright on the African savanna. The first members of the genus Homo were emerging, using simple stone tools, their brains beginning the expansion that would eventually lead to us. Every photon from Andromeda that enters your eye tonight is 2.5 million years old, yet it arrives fresh and unchanged, carrying information about how that galaxy was before humans existed, and we can look even deeper. The Hubble Space Telescope has photographed galaxies over 13 billion light-years away. When we see these ancient galaxies, we're seeing them as they were when the universe was less than 1 billion years old, when the first generations of stars were still forming, when heavy elements were rare, when the cosmos was a very different place than it is today. These galaxies might not even exist anymore in our present. They might have merged with other galaxies, been torn apart by gravitational forces, or evolved into completely different structures. But their light persists, carrying their images across billions of years, turning our telescopes into time machines that can peer into the deep past. The cosmic microwave background radiation, which we'll explore in more detail later, is the oldest light in the universe. Released about 380,000 years after the Big Bang when the universe first became transparent to light. This radiation has been travelling for about 13.8 billion years, and it comes from every direction in the sky. When radio telescopes detect this faint microwave glow, they're receiving the most ancient light possible, a baby picture of the universe from when it was less than 0.03% of its current age. This light has been travelling since long before our galaxy existed, before any of the stars we see in the night sky were born, before the elements that make up our bodies were forged in stellar furnaces. What does all this mean for our question about whether the past still exists? Well, in a very real sense. When we look at the night sky, we're seeing that the past does still exist, at least in the form of light travelling through space. The universe is filled with images from every moment of its history, all travelling outward at the speed of light. If you could instantly teleport to a planet 65 million light-years away and point a powerful enough telescope at Earth, you would see dinosaurs walking around. The light from their era is still travelling outward, an expanding sphere of information carrying the image of a world ruled by giant reptiles. From that distant vantage point, the extinction event that ended the age of dinosaurs hasn't happened yet. The asteroid is still drifting through space, years away from its fateful encounter with Earth. The mammals are still small, nocturnal creatures hiding from predators. Flowering plants are still a relatively recent innovation. The continents are in different positions. It's all there in the light, preserved perfectly, travelling outward at 182 miles per second, a continuous record of everything that has ever been illuminated by our sun. And it's not just Earth. Every star, every planet, every galaxy is constantly broadcasting its history into space in the form of light. The universe is filled with these overlapping spheres of information, each one expanding at the speed of light, carrying images from different times. At any point in space, light from countless different eras is passing through, a rich mixture of past moments all existing simultaneously. If we had eyes sensitive enough, if we had instruments powerful enough, we could in principle observe any moment from the past of any visible object in the universe, as long as we were the right distance away. This raises profound questions about the nature of time and existence. If the past still exists in the form of light travelling through space, if images of every moment are preserved in this expanding sphere of electromagnetic radiation, then in what sense is the past truly gone? The information is still there, still real, still observable from the right vantage point. The photons are real physical entities carrying real information about real events. They're not memories or recordings in the conventional sense. They're the actual light that was present at those past moments, unchanged except for being redshifted by the expansion of space. Consider what happens when you take a photograph. Light from a moment in time enters your camera and is recorded. Later, when you look at the photograph, you're seeing light that represents that past moment. But what we're talking about here is different. The light from the past that fills the universe isn't a representation or a recording. It's the original light itself, still travelling, still carrying its information. In a sense, every point in space is surrounded by a vast sphere of history, with more recent events nearby and more distant events farther away, all of it real, all of it still present in the form of travelling light. This becomes even more interesting when we consider that light itself experiences no time. According to Einstein's theory of special relativity, anything travelling at the speed of light experiences zero passage of time. From a photon's perspective, if a photon could have a perspective, it is absorbed the instant it's emitted, no matter how far it travels. A photon that left a galaxy 10 billion light-years away and enters your eye tonight experiences its entire journey as instantaneous. For the photon, emission and absorption are the same moment. It exists in an eternal now, connecting past and present in a single timeless instant. This means that when you see starlight, you're not just receiving a message from the past. You're connected to that past moment through a photon that from its own reference frame exists outside of time. The star and your eye are linked by something that doesn't experience the intervening years or distance. It's as if the universe has built into its very structure a way for different times to touch each other, for the past to reach into the present through these timeless messengers we call photons. And it's not just visible light. The entire electromagnetic spectrum, from radio waves to gamma rays, carries information from the past. Radio telescopes detect signals from distant galaxies that have been travelling for billions of years. Infrared telescopes see the heat from stars hidden behind clouds of dust, warmth that might have been travelling for millennia. X-ray telescopes observe the violent events around black holes and neutron stars, capturing radiation from cosmic catastrophes that happened when Earth was young, or perhaps before it even existed. Even gravitational waves, those ripples in spacetime itself that we've only recently learned to detect, carry information from the past. When the LIGO and Virgo observatories detect gravitational waves from colliding black holes, they're feeling distortions in space that have been travelling for millions or billions of years. These waves move at the speed of light, carrying information about massive events that happened long ago and far away. The universe, it seems, has multiple ways of preserving and transmitting its history, multiple channels through which the past continues to exist and influence the present. But perhaps the most profound aspect of light as a messenger from the past is what it tells us about our place in the universe. When we look at the night sky, we're not seeing a snapshot of the universe as it is now. We're seeing a complex tapestry of different times, with each object visible at a different moment in its history. The moon as it was a second ago, the sun as it was 8 minutes ago, the nearest stars as they were years ago, distant galaxies as they were billions of years ago. We exist at the centre of our own unique view of cosmic history, a view that no other observer in the universe shares exactly. Every observer in the universe has their own unique light cone, a term physicists use to describe the region of space-time from which light has had time to reach them. Your past light cone includes everything you can see or have ever seen, extending back to the Big Bang itself. Someone on a planet orbiting Proxima Centauri would have a slightly different light cone, seeing Earth as it was 424 years ago, while seeing other stars at different times than we do. Every point in space has its own unique perspective on cosmic history, its own unique collection of past moments visible in the surrounding sky. This leads to a startling realization. There is no universal now that all observers share. What you consider to be happening right now on a distant star might be the past or future from another observer's perspective, depending on their motion relative to you and the star. This isn't just philosophical speculation, it's a consequence of special relativity that has been confirmed by countless experiments. Time is not absolute but relative, and simultaneity, the idea of things happening at the same time, is not a universal concept but depends on your frame of reference. As you lie there in the darkness, perhaps you can feel the gentle rain of photons falling on your skin, each one a messenger from the past. Some left the sun 8 minutes ago, others left distant stars years or centuries ago, and still others, the cosmic microwave background photons, have been travelling since the universe was young. You're immersed in a sea of history, surrounded by the preserved light of countless past moments. The past isn't gone. It's all around you, arriving constantly at the speed of light, an endless stream of information from every moment that has ever been illuminated. And if you think about it, you too are broadcasting your own history into space. Every photon that bounces off you and escapes into the night carries information about this moment outward at the speed of light. Right now, the light from your childhood is some number of light years away, still travelling outward, still carrying the image of who you were then. To an observer the right distance away, that child still exists, still plays, still laughs, frozen in the amber of travelling light. Every moment of your life, every second you've existed, is preserved in an expanding sphere of light spreading outward into the universe. In this way, the universe remembers everything, not in some conscious sense, but in the very structure of how light and information propagate through space. Every event that has ever happened has sent out its light, its gravitational waves, its various forms of radiation, all travelling outward at the speed of light, creating an ever-expanding record of history written in electromagnetic radiation and space-time distortions. The past persists not as memory, but as physical reality, encoded in the countless photons streaming through the cosmos. As we prepare to delve deeper into the nature of space-time itself, remember this. You have already seen that the past still exists. Every time you look at the stars, you're seeing it directly. The past is not gone but is travelling, always at the same speed, always carrying its information forward into the future. And perhaps, if we understood the universe deeply enough, if we could see it from the right perspective, we would realize that all of time, past, present and future, exists simultaneously in some grand structure we're only beginning to glimpse. The stars have been trying to tell us this all along, sending their ancient light to eyes that are just now learning how to see. Imagine time not as a line you walk along, but as a landscape already fully drawn, with every path laid out in quiet stillness, every moment existing simultaneously, like pages in a book that has already been written. This isn't a mystical vision or a poet's dream, but a serious possibility suggested by our most successful theory of gravity and spacetime, Einstein's general relativity. According to this view, which physicists call the block universe or eternalism, the past doesn't disappear and the future isn't yet to be created. Instead, all of time exists at once, spread out like a map, and what we experience as the flow of time is simply our consciousness moving through this four-dimensional landscape, like a train moving through a landscape that was already there before the train arrived and remains after it has passed. To understand this profound idea, we need to gently explore how physicists came to think of time and space as aspects of a single entity called spacetime. For most of human history, space and time seem like completely different things. Space was where things happened, a kind of stage on which the drama of existence played out. Time was what allowed things to change, a universal clock that ticked forward at the same rate for everyone and everything. This intuitive view, formalized by Isaac Newton, worked wonderfully well for describing everyday phenomena and even the motions of planets. But at the beginning of the 20th century, a young patent clerk named Albert Einstein realized that this common-sense view couldn't be quite right. Einstein's insight began with a simple observation. The speed of light is the same for all observers, regardless of how they're moving. This sounds innocuous, but its implications are revolutionary. If you're on a train moving at 60 miles per hour and you throw a ball forward at 20 miles per hour, someone standing on the platform would measure the ball moving at 80 miles per hour. This is simple addition of velocities, and it matches our everyday experience. But light doesn't work this way. If you're on that same train and shine a flashlight forward, both you and the person on the platform measure the light moving at exactly the same speed, 186,282 miles per second. The light doesn't go faster just because you're already moving. This is deeply strange and contradicts our intuition about how motion works. To make sense of this, Einstein realized that space and time must be more flexible than Newton imagined. If the speed of light is constant for all observers, then space and time themselves must stretch and compress to accommodate this fact. When you move very fast, time slows down for you relative to someone at rest. This isn't science fiction. It's been confirmed by countless experiments. Particles called muons, created when cosmic rays hit Earth's atmosphere, live longer than they should because they're moving so fast that time passes more slowly for them. GPS satellites have to account for this time dilation, or they would give incorrect positions. Time, it turns out, is not universal but personal, not absolute but relative. But the story gets even stranger. Not only does motion affect time, but gravity does too. Einstein realized that massive objects bend space-time around them, and this bending is what we experience as gravity. Near a massive object like Earth, time passes more slowly than in deep space. Your head, being slightly farther from Earth's center than your feet, ages slightly faster than your feet do, though the difference is far too small to notice. Near a black hole, this effect becomes extreme. If you could hover just outside a black hole's event horizon while a friend watched from a safe distance, they would see you moving in slow motion, while from your perspective, you would see the outside universe speeding up, stars racing through their life cycles in what seemed like moments. This interconnection of space and time led physicists to stop thinking of them as separate entities and instead consider them as aspects of a single, four-dimensional continuum, space-time. In this view, you don't just have a position in space, you have a position in space-time. Your life isn't just a series of locations, it's a four-dimensional path through space-time, what physicists call a world line. Your world line extends from your birth to your death, a continuous thread through the fabric of space-time, never breaking, never disappearing, just being. Now here's where it gets truly profound. In the equations of general relativity, there's no special now that moves through time. The equations describe the entire four-dimensional structure of space-time all at once, like a map describes an entire landscape, without singling out any particular location as special. Just as all places on a map exist simultaneously, even though you can only be in one place at a time, perhaps all moments in time exist simultaneously, even though you can only experience one moment at a time. The mathematics doesn't describe a universe where moments come into being and then cease to exist. It describes a universe where all moments simply are. This view, sometimes called the block universe, suggests that the universe is like a four-dimensional sculpture, frozen and eternal, with time being just another dimension, like the three dimensions of space. Your entire life, from birth to death, exists as a permanent structure in this four-dimensional block. The baby you once were still exists back there in space-time. The elderly person you might become already exists up ahead in space-time. Every moment of your life exists simultaneously, like different points along a road all exist even though you can only stand at one point at a time. It sounds strange, maybe even wrong, and yet some interpretations of physics suggest something very much like this. The physicist Brian Greene puts it eloquently. Every moment is illuminated and every moment remains illuminated. Every moment is, under close scrutiny, the flowing river of time more closely resembles a giant block of ice, with every moment forever frozen in place. If this view is correct, then the past isn't gone. It's simply elsewhere in space-time, just as Paris doesn't cease to exist when you're in London. The future isn't yet to be created. It already exists, waiting for you to arrive just as the road, the ahead, exists even though you haven't travelled it yet. But wait, you might be thinking, this can't be right. I remember the past but not the future. I can affect the future but not the past. I experience time flowing from past to future, not as a static block. These are valid observations, and physicists have spent decades trying to understand how our subjective experience of flowing time emerges from the static equations of relativity. One possibility is that consciousness itself is what creates the illusion of flow. Perhaps consciousness can only experience one moment at a time, and it's this limitation that makes us feel like time is flowing, when really we're just experiencing different slices of the eternal space-time block in sequence. Think of it like reading a book. The entire book exists all at once, every page, every word already printed and bound. But when you read it, you experience it sequentially, one word at a time, one page at a time. The story seems to unfold, things seem to happen, but really you're just moving your attention through a structure that already exists in its entirety. Perhaps consciousness moves through space-time in a similar way, experiencing the pre-existing structure sequentially, and interpreting this as the flow of time. Another way to think about it uses the metaphor of a movie film. A film consists of thousands of still images, each one slightly different from the last. When played through a projector, these still images create the illusion of motion and change, but the film itself, the actual strip of celluloid, contains all the images at once. You could lay it out on a table and see the entire movie simultaneously, though it wouldn't make much sense viewed that way. Perhaps space-time is like that film strip, containing all moments simultaneously, and consciousness is like the projector, experiencing these moments sequentially and creating the illusion of change and flow. This block universe view has some startling implications. If the future already exists in space-time, does that mean everything is predetermined? Do we have free will, or are we just playing out a script that's already been written? These are deep philosophical questions that physicists and philosophers continue to debate. Some argue that the block universe is compatible with free will because even though your future choices already exist in space-time, they're still your choices. Others argue that true free will requires an open future, and if the future already exists, then free will must be an illusion. But perhaps we're thinking about it wrong. Perhaps the question isn't whether the future is predetermined, but whether the concepts of predetermined and free will even make sense in a block universe. These concepts assume a flowing time where the past is fixed and the future is open. In a block universe, there's no flowing time, so these concepts might be as meaningless as asking whether something is above or below in a universe. Without gravity to define up and down, the block universe doesn't say your choices don't matter, it says your choices, like everything else, are features of the eternal space-time structure. There's experimental evidence that supports aspects of this strange view of time. One of the most famous is the relativity of simultaneity. According to special relativity, two events that appear simultaneous to one observer might not appear simultaneous to another observer moving relative to the first. Imagine you're standing on a train platform and a friend is on a train moving past you at high speed. Lightning strikes both ends of the train simultaneously from your perspective, but from your friend's perspective on the moving train, the lightning strikes are not simultaneous. One happens before the other. Neither perspective is more correct than the other. Simultaneity is relative, not absolute. This has profound implications for our question about whether the past still exists. If simultaneity is relative, then what counts as now depends on your motion. An observer moving very fast relative to you might consider your future to be there now, while another observer moving in the opposite direction might consider your past to be there now. If we take this seriously, it suggests that past, present and future are not absolute categories, but depend on your frame of reference. And if different observers disagree about what's past and what's future, then perhaps all moments exist equally in space-time, and the distinction between past, present and future is just a matter of perspective. The physics of black holes provides another window into the strange nature of space-time. Near a black hole, space-time is so severely warped that space and time almost switch roles. Inside the event horizon, the direction toward the singularity becomes time-like, meaning you can no more avoid moving toward it than you can avoid moving into the future. From outside the black hole, an observer would see you slow down and freeze at the event horizon, your last moment before crossing stretched out to infinity. But from your perspective, you pass through the horizon normally and continue toward the singularity. These different perspectives are both correct. They're just descriptions of the same event from different positions in space-time. Quantum mechanics adds another layer of mystery to our understanding of time. In quantum mechanics, particles don't have definite positions or velocities until they're measured. They exist in a superposition of all possible states, described by a wave function that evolves according to the Schrödinger equation. This equation, like the equations of relativity, is deterministic and time-reversible. It doesn't distinguish between past and future. You can run it backward just as easily as forward. The quantum world, like the relativistic world, seems to suggest that time might not flow the way we think it does. Some physicists have proposed that the arrow of time, our sense that time flows from past to future, emerges from thermodynamics rather than from the fundamental laws of physics. The second law of thermodynamics says that entropy, roughly speaking, the amount of disorder in a system, always increases. This gives time a direction toward increasing entropy. A glass can shatter into pieces, increasing entropy, but pieces don't spontaneously assemble into a glass, which would decrease entropy. Perhaps our perception of time's flow is really just our perception of entropy increasing, of the universe moving from order to disorder. But this raises another puzzle. Why was entropy low in the past? Why did the universe start in such an ordered state that entropy had room to increase? This is sometimes called the past hypothesis, and it's one of the great mysteries of cosmology. If all moments exist simultaneously in the block universe, why does one end of the block have low entropy and the other high entropy? Why is there an arrow of time at all? These questions remain unanswered, reminders that our understanding of time is far from complete. The block universe view might seem to rob life of meaning. If everything already exists, if the future is as fixed as the past, what's the point of trying, of choosing, of living? But perhaps this is looking at it backward. If the block universe is real, then every moment of your life is permanent, eternal, meaningful. That sunset you watched years ago, it still exists back there in space-time as beautiful and real as ever. That moment of joy, that act of kindness, that experience of love, they're all permanent features of the universe, as lasting as the mountains, as eternal as the stars. In this view, nothing is ever truly lost. Every person who has ever lived still exists in space-time. Every moment of beauty, every act of courage, every expression of love is preserved forever in the four-dimensional structure of the block universe. Death is not an ending, but a boundary. Your world line has a beginning and an end, just as a road has a beginning and an end, but the road doesn't cease to exist just because you've reached its end. You're a permanent feature of space-time, a thread woven into the eternal fabric of the universe. This might be why we feel such a deep connection to the past, why memories can be so vivid, why we sometimes feel the presence of loved ones who have died. If the block universe is real, they haven't ceased to exist. They're just elsewhere in space-time, no more gone than a place is gone when you leave it. The past isn't destroyed, it's just inaccessible to us because we can only experience one moment at a time, but it's still there, still real, still part of the eternal structure of existence. Modern physics offers other hints that time might not be fundamental. In some approaches to quantum gravity, the theory that would unite quantum mechanics and general relativity, time disappears entirely at the most fundamental level. The Wheeler-DeWitt equation, sometimes called the timeless equation of quantum gravity, describes the quantum state of the entire universe without any reference to time. Time, in these theories, is emergent, something that appears at large scales but doesn't exist at the deepest level of reality. The universe, at its most fundamental, might be timeless, with time being just a convenient way we organize our experience of it. String theory, one of the leading candidates for a theory of quantum gravity, suggests that space-time itself might be emergent from something more fundamental. In string theory, the basic constituents of reality are not particles, but tiny vibrating strings. These strings exist in a space with more than 4 dimensions, perhaps 10 or 11, with the extra dimensions curled up too small to see. Space-time as we know it might be just a low-energy approximation of this higher dimensional reality. If space-time is emergent, then our usual concepts of past, present, and future might be approximations too, useful at our scale but not fundamental to reality. Even in our everyday experience, there are hints that time might not be what it seems. When you dream, you can experience hours or even years in what's actually just a few minutes of REM sleep. When you're in danger, time seems to slow down, allowing you to perceive and react to things that would normally happen too fast to process. When you're absorbed in something you love, hours can pass in what feels like minutes. These subjective variations in the experience of time suggest that our perception of time is constructed by our brains rather than being a direct perception of something fundamental. The block universe also offers a different perspective on causation. In our everyday view, causes precede effects in time. You drop a glass and then it breaks. But in the block universe, cause and effect are just patterns in the four-dimensional structure. The dropping and the breaking are connected not because one happens before the other, but because they're part of the same four-dimensional pattern. It's like how the summit of a mountain isn't caused by the base, they're just different parts of the same structure. This doesn't mean causation is meaningless, just that it might be more about patterns and correlations in space-time than about one event creating another. As you lie there in the quiet darkness, perhaps you can feel yourself as a four-dimensional being, extended through time as well as space. Your past is not gone but is part of you, stretching back through space-time to your birth and beyond. Your future, whatever it holds, might already exist, waiting for your consciousness to experience it. You're not a three-dimensional being moving through time, but a four-dimensional being experiencing itself one slice at a time. Every moment of your life is equally real, equally present in the grand structure of space-time. This view transforms death from an ending into simply the boundary of your world line in space-time. Just as a river has a source and a mouth, your world line has a beginning and an end, but the entire river exists simultaneously. Future generations looking back at history aren't looking at something that has ceased to exist but at a different region of the eternal space-time block. When we remember the past, we're not recalling something that has vanished, but connecting to a part of space-time that still exists, just not here now. The implications extend to the entire universe. The Big Bang isn't something that happened and is now over. It's a feature of space-time that exists eternally at one end of the block. The heat death of the universe, if it occurs, isn't something that will happen and then be over. It would be an eternal feature at the other end of the block. The entire history of the universe, from beginning to end, might exist as a single, eternal, four-dimensional structure, with nothing ever truly beginning or ending, just being. All around you, though you cannot feel it, the universe is filled with faint glows and quiet ripples from long ago, subtle reminders of events that unfolded when the cosmos was young, when galaxies were just beginning to form, when the first stars were igniting in the darkness. These ancient signals are still traveling through space, passing through your body right now, carrying information from the deep past into the present moment. The universe, it seems, never truly forgets anything. It preserves its history in waves and particles that continue their journeys across billions of years, creating a kind of cosmic memory that surrounds us always, though we've only recently developed the instruments sensitive enough to detect it. The most ancient light we can observe is called the cosmic microwave background, or CMB, and it fills the entire universe with a faint, almost uniform glow. This isn't light from stars or galaxies, but light from the universe itself when it was only 380,000 years old, a baby picture of the cosmos from when it first became transparent to radiation. Before this time, the universe was so hot and dense that light couldn't travel freely. Photons were constantly bouncing off electrons in an opaque fog of particles. But as the universe expanded and cooled, electrons combined with protons to form the first atoms, mostly hydrogen, and suddenly light could travel unimpeded through space. That first light has been travelling ever since, stretched by the expansion of space from visible light into microwave radiation, creating a faint background glow that comes from every direction in the sky. When you tune an old analog television to a channel with no station, about 1% of the static you see is this ancient light, these photons from the early universe interfering with your TV's circuits. Think about that for a moment. In the static on a dead channel, you're literally seeing the echo of the Big Bang, receiving photons that have been travelling for 13.8 billion years just to create a tiny bit of snow on your screen. Every cubic centimetre of space contains about 400 of these CMB photons, so in the space occupied by your body right now, there are trillions of these ancient particles of light, messengers from a time before stars, before galaxies, before any structure we would recognise in today's universe. The cosmic microwave background was predicted before it was discovered, a triumph of theoretical physics. In the 1940s, physicists working out the implications of the Big Bang theory realized that if the universe began in a hot, dense state and has been expanding and cooling ever since, there should be leftover radiation from that early epoch, cooled by expansion to just a few degrees above absolute zero. They calculated that this radiation should be detectable as microwaves coming uniformly from all directions. But it wasn't until 1964 that two radio astronomers, Arno Penzias and Robert Wilson, accidentally discovered this background radiation while trying to eliminate noise from their antenna. They thought they had a problem with pigeon droppings in their equipment, but after cleaning everything and still detecting the signal, they realized they had discovered the echo of creation itself. What's remarkable about the cosmic microwave background is how uniform it is. No matter which direction we look, the temperature of this radiation is almost exactly the same. 2.725 degrees above absolute zero. The variations are tiny, less than 1 part in 100,000, like ripples on an otherwise perfectly calm sea. These tiny variations are incredibly important though. They represent slight differences in density in the early universe, the seeds that would eventually grow into galaxies and galaxy clusters. Where the CMB is slightly warmer, the early universe was slightly denser, and these denser regions had slightly stronger gravity, pulling in more matter over billions of years until they formed the cosmic structures we see today. By studying these tiny variations in unprecedented detail, scientists have been able to determine the age of the universe, 13.8 billion years, its composition, about 5% ordinary matter, 27% dark matter, and 68% dark energy, and its geometry, flat to within observational error. It's as if the universe left us a detailed birth certificate, written in microwave radiation, containing precise information about its origin and early history. Every improvement in our ability to measure the CMB reveals new details about the cosmos, like developing a photograph with ever-increasing resolution. The cosmic microwave background also tells us something profound about our question of whether the past still exists. These photons are not recordings or memories of the early universe. They're actual particles that existed then and have been travelling through space ever since. When a CMB photon enters a radio telescope, it's the same photon that was released 13.8 billion years ago, unchanged except for being stretched to a longer wavelength by the expansion of space. In a very real sense, when we observe the CMB, we're not just learning about the early universe, we're directly observing it. The past, at least this particular past, hasn't disappeared. It's still arriving, still present, still real. But the cosmic microwave background is just one of many ways the universe preserves and transmits its history. In 2015, humanity detected another kind of echo from the past: gravitational waves. These are ripples in spacetime itself predicted by Einstein a century ago, but so faint that he doubted they would ever be detected. Gravitational waves are produced whenever massive objects accelerate, but only the most violent events in the universe produce waves strong enough for us to detect. When two black holes spiral into each other and merge, they send out gravitational waves like ripples on a pond, except these ripples are in the fabric of space and time themselves. The first gravitational waves ever detected came from two black holes, each about 30 times the mass of our Sun, that collided 1.3 billion years ago. For millions of years, these black holes orbited each other, slowly spiraling inward as they lost energy to gravitational radiation. In the final fraction of a second before they merged, they were moving at half the speed of light, distorting spacetime so violently that they radiated away energy, equivalent to 3 times the mass of our Sun, converted entirely into gravitational waves. This was one of the most energetic events in the universe since the Big Bang, yet by the time these waves reached Earth, they had weakened so much that they stretched and compressed the 4-kilometer arms of the LIGO detectors by less than 1,000th the width of a proton. Think about what this means. An event that happened when complex life on Earth was just beginning to flourish in the oceans, when the most sophisticated organisms were simple, multicellular creatures, sent out waves that have been travelling through space ever since, gradually spreading and weakening but never disappearing. These waves passed through countless galaxies, through vast voids of empty space, through regions where stars were being born and dying, carrying their message unchanged across more than 1 billion years, and then, at precisely 50:45 UTC on September 14, 2015, They pass through Earth, slightly squeezing and stretching our planet and everything on it, including you if you were alive then, though the effect was far too small to feel. Since that first detection, we've observed dozens of gravitational wave events, black holes merging, neutron stars colliding, possibly even black holes swallowing neutron stars. Each event sends out ripples that travel at the speed of the light, carrying information about some of the most extreme phenomena in the universe. When two neutron stars collided in 2017, we detected both gravitational waves and light, from the event seeing it happen in multiple ways simultaneously. The gravitational waves arrived first, followed 1.7 seconds later by a gamma-ray burst, then visible light, then other forms of radiation over the following days and weeks. This single event, designated GW170817, was observed by over 70 telescopes and gravitational wave detectors, making it one of the most studied events in astronomical history. What made GW170817 special wasn't just that we detected it in multiple ways, but what it told us about the universe. The neutron star collision created and dispersed heavy elements like gold, platinum and uranium into space. The light we observed had signatures of these elements, confirming decades-old theories about where heavy elements come from. It's likely that the gold in any jewellery you own was created in a similar neutron star collision billions of years ago. The atoms forged in that violent event and then drifting through space for eons before becoming part of the cloud that formed our solar system. You carry within you atoms that remember cosmic violence from before Earth existed, elements that were created in seconds but have lasted billions of years. The universe preserves its history in other subtle ways too. Neutrinos, those ghostly particles that barely interact with matter, fill the universe with their own cosmic background. Every second, about 100 trillion neutrinos pass through your body, most of them relics from the Big Bang, though some come from the Sun, from supernovae, from cosmic ray collisions in Earth's atmosphere. These particles are so reluctant to interact with matter that they can pass through the entire Earth as if it weren't there. A neutrino could travel through a light year of solid lead and have only a 50% chance of hitting anything. Yet they're everywhere, outnumbering atoms by about 1 billion to 1, the invisible sea of particles carrying information from various epochs of cosmic history. There should be a cosmic neutrino background from the early universe, similar to the cosmic microwave background but from an even earlier time, just 1 second after the Big Bang. These relic neutrinos would be incredibly difficult to detect because they have so little energy after being cooled by 13.8 billion years of cosmic expansion. But they're predicted to be there, filling every cubic centimetre of space with about 330 ancient neutrinos, particles that have been travelling since before atoms existed, before light could travel freely, from a time when the entire observable universe was compressed into a region smaller than our solar system. If we could detect these relic neutrinos, we would be observing the universe as it was just 1 second old, seeing even deeper into the past than the cosmic microwave background allows. The universe also remembers its history through the distribution of matter on the larger scales. When we map the positions of millions of galaxies, we find they're not randomly scattered but arranged in a vast cosmic web with galaxies strung along filaments, clusters at the intersections and vast voids in between. This structure grew from those tiny density variations in the early universe that we see in the cosmic microwave background. Through billions of years of gravitational attraction, those slight overdensities pulled in more matter, growing from ripples barely 1 part in 100,000 to the dramatic structures we see today, with galaxy clusters containing thousands of galaxies and voids spanning hundreds of millions of light years. This cosmic web is like a 3-dimensional map of how gravity has operated over cosmic time. Every galaxy's position tells a story of billions of years of gravitational interaction, of slow drift through space, of mergers with other galaxies, of infall into clusters. The universe has been keeping track of every gravitational interaction, encoding the results in the positions and motions of billions of galaxies. When we simulate the growth of structure on supercomputers, starting from those tiny variations in the CMB and letting gravity operate for 13.8 billion years, we get a cosmic web that looks remarkably like what we observe. The past has shaped the present in ways we can calculate and verify, showing that the universe has been faithfully preserving and processing information since its beginning. Even the chemical composition of stars tells stories from the past. The first stars contained only hydrogen and helium, the elements created in the Big Bang. When these stars died, some in spectacular supernova explosions, they scattered heavier elements into space. The next generation of stars formed from gas enriched with these heavier elements, and when they died, they added even more complexity to the cosmic chemistry. Each generation of stars has left its mark on the universe's chemical composition, like tree rings recording years of growth. By studying the spectra of stars, the patterns of light that reveal their chemical composition, we can determine when they formed and what previous generations of stars contributed to their makeup. Our Sun is a third-generation star, containing elements from at least 2 previous generations of stellar death and rebirth. The oxygen you breathe, the carbon in your DNA, the iron in your blood, all were created in stars that died before our Sun was born. But not all heavy elements come from regular stellar death. Elements heavier than iron, like gold and uranium, require more extreme conditions. Some are created in supernova, but many, we now know from observations like GW 1700807, are created when neutron stars collide. Every element tells a story of its creation, preserving information about events that happened billions of years ago in stars and stellar collisions far from here. The cosmic rays that constantly bombard Earth are another form of memory, high-energy particles accelerated by supernova, black holes and other violent events, sometimes from billions of light-years away. When a cosmic ray particle strikes Earth's atmosphere, it creates a shower of secondary particles that rain down on the surface. Some of these cosmic rays have energies far beyond anything we can create in particle accelerators, carrying information about the most extreme environments in the universe. They've been traveling for millions or billions of years, bent by magnetic fields, scattered by interstellar gas, but still carrying information about their origins in their energy and composition. Even seemingly empty space preserves information from the past. Quantum field theory tells us that empty space isn't really empty, but filled with quantum fields that are constantly fluctuating, creating virtual particles that appear and disappear in tiny fractions of a second. These quantum fluctuations were stretched during cosmic inflation, the period of exponential expansion in the universe's first fraction of a second, becoming the seeds of structure we see in the cosmic microwave background. In a sense, the larger structures in the universe, clusters and superclusters of galaxies spanning hundreds of millions of light-years, grew from quantum fluctuations smaller than an atom that occurred in the first 10^32 seconds after the Big Bang. The universe has amplified and preserved these tiniest of fluctuations into the grandest of structures. Dark matter, that mysterious substance that makes up 27% of the universe but doesn't interact with light, might also be a relic from the early universe. We don't know what dark matter is, but we can see its gravitational effects on galaxies and galaxy clusters. It might consist of particles created in the first second after the Big Bang, particles that have been drifting through space ever since, interacting only through gravity, shaping the formation of galaxies while remaining invisible. Every galaxy is surrounded by a halo of dark matter, an invisible cloud that remembers the conditions of the early universe and has been influencing cosmic evolution ever since. The expansion of space itself is a kind of memory. The universe is expanding, with space itself stretching, carrying galaxies apart like raisins in rising bread dough. This expansion has been happening since the Big Bang, and its rate carries information about the universe's history. By measuring how fast galaxies are moving away from us at different distances, we can reconstruct the expansion history of the universe, learning that the expansion is actually accelerating due to dark energy. Every galaxy's recession velocity is a fossil record of cosmic expansion, preserving information about how space has stretched over billions of years. Even the temperature of space tells a story. In the emptiest regions between galaxies, far from any stars, space has a temperature of 2.725 degrees above absolute zero, the temperature of the cosmic microwave background. This temperature has been dropping as the universe expands, and it will continue to drop in the future. Billions of years ago, space was warmer. Billions of years from now, it will be colder. The current temperature is a precise marker of our moment in cosmic history, a timestamp written in the energy of empty space itself. Black holes might be the ultimate preservers of information. According to quantum mechanics, information cannot be destroyed, yet black holes seem to violate this principle by swallowing matter and energy behind event horizons from which nothing can escape. This information paradox has puzzled physicists for decades. Stephen Hawking proposed that black holes slowly evaporate through quantum effects, radiating away their mass as Hawking radiation. But this radiation appears to be random, containing no information about what fell into the black hole. Recent theoretical work suggests that information might be preserved in subtle correlations in the Hawking radiation or encoded on the black hole's event horizon in a kind of hologram. If this is correct, black holes don't destroy information but preserve it in a scrambled form, perhaps releasing it back into the universe over vast timescales as they evaporate. As you lie there in the darkness, surrounded by these invisible signals from the past, you might wonder what new forms of cosmic memory we have yet to discover. Perhaps there are particles or waves we haven't detected yet, carrying information from even earlier times or from events we can't yet imagine. Perhaps the dark matter that shapes our galaxy is constantly whispering secrets from the early universe, if only we knew how to listen. Perhaps space itself at the smallest scales contains a record of everything that has ever happened, encoded in quantum fluctuations too subtle for our current instruments to detect. The discovery of gravitational waves opened an entirely new window on the universe, letting us hear cosmic events for the first time. What other senses might we develop? What other messengers from the past are streaming through space, waiting for us to build the right detectors? Each new way of observing the universe has revealed previously hidden aspects of cosmic history. Radio astronomy showed us pulsars and quasars. X-ray astronomy revealed black holes and neutron stars. Infrared astronomy let us peer through cosmic dust to see stellar nurseries. Neutrino astronomy is showing us the hearts of supernovae and the most violent cosmic accelerators. Gravitational wave astronomy is revealing merging black holes and neutron stars. What will we discover next? The universe seems to be extraordinarily good at preserving information, at remembering its past. From the cosmic microwave background to gravitational waves, from the distribution of galaxies to the chemistry of stars, from cosmic rays to quantum fluctuations, the cosmos has kept detailed records of its history. These aren't metaphorical records, but physical phenomena, actual particles and waves and structures that have persisted across billions of years. The past hasn't disappeared. It has left traces everywhere, in every photon, every atom, every ripple of space-time. We are surrounded by the preserved history of the universe, immersed in signals from every epoch of cosmic time. Beneath your feet, whether you're lying in bed or sitting in a chair or standing on solid ground, the Earth itself is layered with stories, each rock and fossil a page from another age, each grain of sand a fragment of deep time made tangible. The planet we call home is not just a ball of rock floating in space, but a vast archive, a library of stone and soil and sediment that has been recording and preserving the history of our world for 4.5 billion years. Every mountain, every valley, every pebble on a beach contains information about the past, encoded in its composition, structure, and position. The Earth remembers everything, every asteroid impact, every volcanic eruption, every ice age, every form of life that has ever existed. And you, made of Earth's matter, reorganized into human form, are both a reader of this archive and a part of it, your very atoms carrying memories of cosmic and geological events stretching back to the birth of the universe. Let's begin with something you can hold in your hand, a simple rock. Pick up any rock, anywhere on Earth, and you're holding deep time in your palm. That rock has a story that might stretch back millions or billions of years. If it's granite, it formed deep underground as magma slowly cooled, crystals of quartz and feldspar and mica growing over thousands of years in the darkness. If it's sandstone, it's made of countless grains of sand that were once part of other rocks, eroded by wind and water, transported by rivers, deposited in ancient seas or deserts, then compressed and cemented together over millions of years. If it's limestone, it might be made almost entirely of the shells and skeletons of marine organisms that lived hundreds of millions of years ago, their bodies becoming rock, their forms sometimes still visible as fossils embedded in the stone. The Earth's crust is like a book written in stone, with older pages generally deeper and younger pages near the surface. Though the tremendous forces of plate tectonics have folded, faulted, and shuffled these pages in complex ways. In places like the Grand Canyon, erosion has exposed this book's pages in dramatic cross-section, revealing nearly 2 billion years of Earth history in colourful layers. Each layer tells a story: red sandstone from ancient deserts, grey limestone from tropical seas, black shale from deep ocean basins. The boundaries between layers often mark dramatic events: mass extinctions, climate changes, asteroid impacts. The rock layers are like tree rings on a planetary scale, recording the conditions when they formed. Some rocks are truly ancient. The oldest rocks on Earth's surface are about 4 billion years old, found in places like the Canadian Shield, Western Australia, and Greenland. These rocks formed when Earth was a very different planet. No oxygen in the atmosphere, no life on land, no oceans as we know them today. Yet they've survived all the changes since then, witnessing the rise of life, the oxygenation of the atmosphere, the assembly and breakup of supercontinents, countless ice ages and warm periods. They're time capsules from Earth's youth, and by studying their chemistry and structure, we can reconstruct what our planet was like when it was only 500 million years old. But even older than the oldest rocks are some of the minerals within them. Zircon crystals, incredibly durable and resistant to change, can survive even when the rocks containing them are melted and reformed. The oldest zircons found on Earth are 4.4 billion years old, formed when our planet was only 150 million years old. These tiny crystals, some no bigger than the width of a human hair, contain chemical clues about Earth's earliest days. Their composition suggests that Earth had liquid water, and possibly even continents much earlier than previously thought. Each zircon crystal is like a message in a bottle from Earth's infancy, preserving information that would otherwise be lost. The Earth's layers go much deeper than the rocks we can see and touch. Beneath the crust lies the mantle, 1/800 miles of hot rock that flows like extremely thick honey over geological timescales. Below that is the outer core, 400 miles of liquid iron and nickel, and at the very centre, the inner core, a solid iron sphere the size of the moon, pressed into existence by the tremendous pressure of the overlying layers. We can't directly sample these deep layers, but we can study them through seismic waves, vibrations from earthquakes that travel through the Earth and change speed and direction depending on what they pass through. Every earthquake is like a sonogram of Earth's interior, revealing structures and compositions hidden from direct observation. The Earth's magnetic field, generated by the churning liquid iron in the outer core, has been protecting our planet from solar wind and cosmic radiation for billions of years. This magnetic field occasionally reverses, with north becoming south and vice versa, and these reversals are recorded in volcanic rocks and ocean floor sediments. When lava cools, magnetic minerals within it align with Earth's magnetic field at that time, preserving a record of the field's orientation. By studying these magnetic signatures in rocks of different ages, scientists have reconstructed the history of Earth's magnetic field, finding that it has reversed hundreds of times, sometimes staying stable for millions of years, other times flipping several times in a million years. The ocean floor is striped with these magnetic reversals, parallel bands of normal and reversed magnetization that prove the seafloor is spreading and provide a timeline for plate tectonics. Fossils are perhaps the most evocative form of Earth's memory, preserving not just minerals and rocks, but the forms and sometimes even the behaviors of ancient life. When an organism dies under the right conditions, quickly buried in sediment before it can decay or be scattered, its hard parts, bones, shells, teeth, can be replaced molecule by molecule with minerals, turning living tissue into stone while preserving the original shape in extraordinary detail. Sometimes even soft tissues are preserved. Skin impressions, feathers, even the contents of stomachs, frozen moments of ancient life captured in rock. The fossil record is far from complete. Most organisms that have ever lived left no fossils, and most fossils that formed have been destroyed by erosion or melting, but what remains is still extraordinary. We have fossils of bacteria from 3.5 billion years ago, among the earliest evidence of life on Earth. We have fossils of the strange Ediaca and fauna from 600 million years ago, soft-bodied organisms unlike anything alive today, Earth's first experiment with large, complex life. We have fossils from the Cambrian explosion 540 million years ago, when most major animal body plans first appeared in a relatively short period of evolutionary innovation. We have countless fossils of trilobites, those armoured arthropods that dominated the oceans for 270 million years before going extinct. We have fossils of fish with legs, documenting the transition from water to land. We have fossils of dinosaurs with feathers, showing the evolution of birds. We have fossils of human ancestors, revealing our own deep history. Some fossils preserve behavior frozen in time. There are fossils of dinosaurs sitting on nests protecting their eggs, fossils of predators with prey still in their mouths, fossils of animals killed and buried while fighting, fossils of footprints and trackways showing how ancient creatures moved, fossils of burrows and nests preserving the homes of long-extinct animals, even fossils of raindrops, preserving the pattern of a shower that fell hundreds of millions of years ago. Each fossil is a window into a moment in the past, a glimpse of life as it actually was, not as we imagine it might have been. The Earth also preserves its history in ice. In Greenland and Antarctica, snow has been falling and compressing into ice for hundreds of thousands of years, creating ice sheets miles thick. Each year's snowfall creates a distinct layer, and by drilling deep into these ice sheets and extracting cores, scientists can read the history of Earth's climate like tree rings. The ice contains trapped air bubbles, tiny samples of ancient atmosphere that tell us the concentration of greenhouse gases in the past. It contains volcanic ash from eruptions, dust from droughts, even radioactive isotopes from nuclear tests. The deepest ice cores go back 800,000 years, covering multiple ice ages and warm periods, showing how Earth's climate has changed naturally, and how current human-caused changes compare to natural variations. Tree rings provide another form of Earth's memory, one that bridges human and geological timescales. Each year, a tree adds a new ring of growth, wide in good years with plenty of rain, narrow in years of drought or cold. By studying tree rings, scientists can reconstruct climate conditions year by year going back thousands of years. The oldest living trees, bristlecone pines in California and Nevada, are over 5,000 years old, each one a living record of 5 millennia of climate. By matching overlapping ring patterns from living trees, dead trees, and ancient wood preserved in bogs or buildings, scientists have created continuous tree ring chronologies going back over 12,000 years in some regions. These chronologies are so precise they can identify specific years, even specific seasons, in the deep past. The ocean floor is another archive, accumulating sediment at rates of millimeters to centimeters per 1,000 years. These sediments contain shells of microscopic marine organisms, volcanic ash, dust blown from continents, even microscopic meteorites from space. By drilling into ocean sediments, scientists can recover cores that record millions of years of Earth history. The types of microscopic fossils change with ocean temperature and chemistry. The composition of their shells records the temperature and salinity of ancient seas. Layers of volcanic ash mark major eruptions. Changes in sediment type reveal shifts in ocean currents and climate. The ocean floor remembers everything that has happened in and above it, a vast library written in mud and ooze. But Earth's memory goes even deeper than rocks and fossils and ice. Every atom on our planet, except for hydrogen and some helium, was forged in the nuclear furnaces of stars that died before our sun was born. The Earth itself is made of stardust, atoms that remember stellar fires from billions of years ago. When a massive star explodes as a supernova, it creates and disperses elements heavier than iron, gold, uranium, lead, all the heaviest elements on the periodic table. These atoms drift through space for millions or billions of years before being incorporated into new stars and planets. The gold in any jewelry you might wear was created in a stellar explosion or neutron star collision billions of years ago. It has been part of asteroids, part of Earth's core, part of rocks and rivers, and now temporarily part of a human artifact. But it remembers, in its nuclear structure, the unimaginable violence of its birth. Your body is made of these recycled atoms. The carbon in your DNA, the calcium in your bones, the iron in your blood, all have histories stretching back billions of years. That carbon atom might have been part of limestone in an ancient seabed, dissolved by rain, absorbed by a plant, eaten by a dinosaur, expelled as waste, buried and compressed into rock, uplifted by tectonic forces, eroded again, dissolved in the ocean, incorporated into plankton, settled to the seafloor, subducted into the mantle, expelled by a volcano, weathered into soil, absorbed by another plant, and eventually eaten by you. Each atom in your body has been on an incredible journey, part of countless different structures, yet maintaining its identity as carbon or calcium or iron throughout. Water molecules have their own memories. The water you drink has been cycling through Earth's hydrological system for billions of years. It has been ocean and cloud, rain and snow, ice and vapour, groundwater and river. It has been inside countless living things, drunk by dinosaurs, incorporated into ancient trees, cycled through bacterial cells billions of times. Some water molecules in your body right now were probably also in the bodies of historical figures, in Shakespeare, in Cleopatra, in unnamed ancestors who lived thousands of years ago. Water has a kind of immortality, constantly recycled but never destroyed, carrying within its molecular structure the same hydrogen that formed in the Big Bang and oxygen forged in ancient stars. Even DNA is a form of memory, encoding information not just about how to build and operate a living organism, but about its evolutionary history. Your DNA contains genes that you share with all other humans, genes that reveal our common ancestry. But it also contains genes you share with all mammals, revealing an older common ancestry, and genes you share with all animals, with all eukaryotes, with all life on Earth. Some of your genes are virtually identical to genes in bacteria, unchanged after billions of years, encoding fundamental processes that all life shares. Your DNA is a historical document, a record of successful adaptations and innovations stretching back to the origin of life itself. Some of your DNA isn't even originally human. About 2% of the DNA in people of non-African descent comes from Neanderthals, inherited from interbreeding that occurred 40,000 to 60,000 years ago. Some people also carry DNA from Denisovans, another extinct human species. Viruses have inserted their DNA into our genomes throughout evolution, and about 8% of your DNA consists of these viral remnants, most now inactive, but some possibly playing important roles in development and immunity. Your genome is a patchwork of different sources, a genetic memory of encounters and mergers stretching back through deep time. The Earth preserves memories of catastrophes as well as gradual changes. The Chicxulub crater in Mexico, now buried under younger sediments but still detectable through gravitational and magnetic anomalies, marks where a 6-mile-wide asteroid struck Earth 66 million years ago, ending the age of dinosaurs. A thin layer of iridium-rich clay found worldwide at the boundary between Cretaceous and Paleogene rocks is the fallout from that impact, a global shroud of asteroid dust that settled over the entire planet. Shocked quartz crystals, formed only under extreme pressure, are found in this layer along with tiny glass spheres that were molten rock ejected from the impact. The Earth remembers this catastrophic day in multiple ways, preserving evidence of an event that redirected the course of evolution. Volcanic eruptions leave their own distinctive memories. The eruption of Mount Vesuvius in 79 CE preserved the Roman cities of Pompeii and Herculaneum under ash, creating detailed snapshots of daily life in the ancient world. The eruption of Tambora in 1815 ejected so much ash into the atmosphere that 1816 became known as the year without a summer, recorded in tree rings, ice cores, and historical accounts worldwide. The eruption of Toba 74,000 years ago, one of the largest in human prehistory, left ash deposits across much of Asia and may have caused a volcanic winter that nearly drove humanity extinct, with genetic evidence suggesting the human population dropped to perhaps just a few thousand individuals. Climate changes are recorded in multiple ways. Ice ages leave distinctive marks, U-shaped valleys carved by glaciers, moraines of debris left by retreating ice, scratches on bedrock showing the direction ice moved, erratics, boulders carried far from their origin by glaciers, and the bones of cold-adapted animals like mammoths found far from today's Arctic. Warm periods leave their own signatures, fossil coral reefs in what are now temperate zones, crocodile fossils in the Arctic, coal deposits formed from tropical swamps in Antarctica. The Earth's climate history is written in rocks and fossils, in ice and sediment, a detailed record of how our planet's surface conditions have varied over billions of years. Even human activity is being preserved in Earth's geological record. We are creating what some scientists call the Anthropocene, a new geological epoch defined by human impact. Future geologists will find a sharp increase in radioactive isotopes from nuclear weapons testing, a layer of plastic particles that didn't exist before the 20th century, changes in sediment patterns from agriculture and urbanization, extinction events and invasive species distributions linked to human activity, and altered chemistry in rocks and sediments from industrial pollution. We are writing our own chapter in Earth's stone book, though what story it will tell depends on choices we have yet to make. The Earth also preserves information through chemical cycles. The carbon cycle moves carbon between atmosphere, oceans, life, soil, and rocks over timescales from days to millions of years. The nitrogen cycle, the phosphorus cycle, the water cycle, all involve elements and compounds moving through different reservoirs, carrying information about conditions and processes. When carbon dioxide dissolves in the ocean, it leaves a chemical signature. When plants photosynthesize, they preferentially use certain isotopes of carbon, leaving a distinctive isotopic signature in organic matter. These chemical signals are preserved in rocks and fossils, allowing us to reconstruct ancient atmospheres, oceans, and ecosystems. Plate tectonics itself is a form of memory. The continents preserve in their rocks a record of collisions and rifting stretching back billions of years. Mountain ranges mark where continents collided. The Himalayas are still rising as India pushes into Asia. The Appalachians are the eroded remnants of a collision 300 million years ago. Rift valleys mark where continents are pulling apart. The East African Rift may eventually split Africa in two. The Atlantic Ocean is still widening as the Americas drift away from Europe and Africa. The positions and movements of continents affect ocean currents, climate patterns, and the distribution of life. The current configuration of continents is just a snapshot in an ongoing dance that has been reshaping Earth's surface for billions of years. Even extinction events, those times when large percentages of species disappeared, are preserved in multiple ways. The fossil record shows sudden disappearances of previously common organisms. Rock chemistry changes as ocean chemistry and atmospheric composition shift. Fungal spores often increase as dead organisms provide abundant food for decomposers. Recovery patterns, the sequence in which life rebounds, are also preserved. The Earth remembers not just the extinctions but the recoveries, the innovations that followed catastrophes, the new forms of life that emerged to fill empty, ecological niches. As you lie there, remember that you're lying on top of 4.5 billion years of accumulated history. Beneath you, layer upon layer of rock preserves the story of our planet. Around you, every atom has a history stretching back to the Big Bang. Within you, DNA encodes billions of years of evolutionary history. You're not separate from this deep history, but part of it, a recent chapter in an ongoing story. The calcium in your bones might once have been part of a trilobite's shell. The iron in your blood might once have flowed in the veins of a dinosaur. The water in your cells has cycled through countless organisms over billions of years. The Earth's memory is not perfect or complete. Erosion destroys rocks and fossils. Subduction carries ocean floor into the mantle where it melts. Metamorphism alters rocks so thoroughly that their original nature is obscured. But what remains is still extraordinary, a partial but extensive record of our planet's history. And new techniques keep revealing information we didn't know was preserved. Molecular fossils, organic molecules that survive in rocks long after visible fossils are gone. Ancient DNA recovered from bones and sediments. Isotopic signatures that reveal temperatures, rainfall, and vegetation from millions of years ago. The more closely we look, the more memories we find preserved in Earth's rocks and minerals, ice and sediment, water and air. This is what makes Earth special among the planets we know. Not just that it has life, but that it preserves the history of that life and the history of the non-living world that made life possible. Mars might have had life billions of years ago, but much of its geological record has been erased by billions of years of erosion, without the plate tectonics to create new rocks, or the water cycle to deposit new sediments. Venus has been resurfaced by volcanism, erasing most of its older history. But Earth, with its unique combination of plate tectonics, water, life, and moderate conditions, has maintained an extensive archive of its past. Our planet is a memory bank, a library, a museum of deep time, and we're just beginning to learn how to read its collections. Every science that studies Earth's past, from geology to paleontology, from climatology to evolutionary biology, is essentially a form of reading, deciphering the various languages in which Earth has written its autobiography. And what a story it tells, of a planet born in violence, gradually cooling and stabilizing, developing oceans and atmosphere, somehow sparking into life, that life slowly transforming the entire planet, surviving catastrophes, evolving incredible diversity, eventually producing creatures capable of reading the very story of which they are part. You, our Earth, become conscious of itself, able to discover and appreciate its own deep history. Close your eyes and imagine a quiet vantage point far from Earth, perhaps on a planet orbiting a star in a distant galaxy, where light from long ago is just now arriving, carrying images of worlds that no longer exist in the forms we remember them. From this distant place, with a telescope of impossible power, you could look back at Earth and see not the world of today, but the world as it was millions of years ago. The dinosaurs would still rule the land, the continents would be in different positions, and humanity wouldn't even be a possibility yet. This isn't fantasy, but a consequence of the finite speed of light. The past literally still exists out there in space, preserved in electromagnetic radiation that has been travelling outward since the events occurred. Every moment that has ever been illuminated continues its journey through the cosmos, an expanding sphere of information that never truly disappears, only grows fainter and more distant with time. Let's drift together through these possibilities, not as firm predictions or scientific certainties, but as gentle imaginings of how the universe might allow us to look more deeply into its history. Think of this as a peaceful meditation on the nature of time and observation, a quiet exploration of what it might mean if we could somehow visit or observe the past more directly than we currently can. We're not building time machines here, not in any conventional sense, but we are exploring the various ways that physics suggests the past might be more accessible than our everyday experience suggests. Consider first the simplest form of time travel into the past, one that we've already discussed, looking at distant objects. When astronomers point their telescopes at a galaxy billions of light years away, they're quite literally observing the past. But what if we could enhance this natural time machine? What if, instead of being limited to observing distant galaxies as they were billions of years ago, we could observe Earth itself from a great distance? Imagine an advanced civilization on a planet 65 million light years away, pointing their telescopes at Earth right now. They would see our planet as it was during the age of dinosaurs. They would see Tyrannosaurus rex hunting Triceratops, pterosaurs soaring through ancient skies, and the asteroid that would end it all still drifting harmlessly through space, years away from its fateful encounter. Now imagine if we could somehow travel instantly to that distant planet, though of course we can't, as nothing can travel faster than light. But in our gentle imagination, suppose we could. We would arrive to find their telescopes showing us Earth's deep past in real time, or rather, in the delayed time that light requires to cross such vast distances. We could watch the age of dinosaurs unfold, see the asteroid impact, observe the rise of mammals, witness the evolution of humans, all playing out like a cosmic movie that has been travelling through space for millions of years. The information is real. The photons are the actual light that reflected off dinosaurs and ancient landscapes. It's not a recording or a simulation, but the original light itself, preserved in its journey through the vacuum of space. But perhaps we don't need to travel to distant planets to observe the past. Perhaps there are more subtle ways the universe might allow us to peer backward through time. Consider gravitational lensing, the way massive objects bend space-time, and therefore bend the paths of light passing near them. When light from a distant galaxy passes by a closer galaxy cluster, the cluster's gravity can bend and focus that light like a lens, creating multiple images or distorted arcs of the background galaxy. Sometimes these different light paths have different lengths, meaning the light takes different amounts of time to reach us. We see the same event, like a supernova explosion, happening at different times in different images of the same galaxy. The universe has created a natural time delay system, showing us the same event from multiple temporal perspectives. What if we could enhance this effect? What if, somewhere in the universe, there are natural configurations of massive objects that create more complex gravitational lenses, bending light in ways that allow much longer delays? Perhaps there are cosmic arrangements that could bend Earth's own light back toward us, letting us see our own past. Imagine light from Earth thousands or millions of years ago, bent by the gravity of distant galaxies or black holes, following a curved path through space that eventually brings it back to where it started. We would be seeing ourselves as we were, receiving our own ancient light after it had taken a grand tour of the cosmos. It would be like looking in a mirror that reflects not your current appearance, but how you looked years ago. A a temporal mirror created by the curvature of spacetime itself. Wormholes, those hypothetical shortcuts through spacetime, offer another possibility for observing or even visiting the past. While we have no evidence that wormholes exist, they are allowed by the mathematics of general relativity. A wormhole would be a tunnel through spacetime, connecting two distant regions. If one end of a wormhole could be accelerated to near light speed, or placed in a strong gravitational field, time dilation would cause time to pass at different rates at the two ends. One end would age more slowly than the other, creating a time difference between them. If you entered the younger end and emerged from the older end, you would have travelled into the past, at least relative to the reference frame you started in. But let's imagine something gentler, less dramatic than jumping through wormholes. What if wormholes, should they exist, could be used simply as windows rather than doorways? Perhaps we could peer through them without travelling through them, observing the past without the paradoxes that might come from actually visiting it. A network of such temporal windows scattered through space could allow observations of different eras, different moments, creating a kind of cosmic museum where the exhibits are actual moments from history, viewed through the curved glass of space-time itself. You could walk from window to window seeing Earth at different stages, the formation of the Moon, the first emergence of life, the Cambrian explosion, the age of dinosaurs, the rise of humans, all visible through these hypothetical portals in space-time. The quantum realm offers its own strange possibilities for accessing information from the past. In quantum mechanics, particles can be entangled, meaning their properties remain correlated even when separated by vast distances. When you measure one entangled particle, you instantly know something about its partner, regardless of how far apart they are. This isn't communication in the classical sense, as no information travels between the particles, but it does suggest that the universe has non-local connections that transcend our usual understanding of space and separation. What if similar connections exist across time? What if particles entangled in the past maintain some quantum correlation with particles in the present? Some interpretations of quantum mechanics suggest that the wave function, the mathematical object that describes quantum possibilities, doesn't collapse into a single outcome when measured, but branches into multiple parallel realities, each representing a different outcome. In this many worlds interpretation, every possible version of history exists simultaneously in parallel universes. The past isn't gone, it exists in other branches of the universal wave function. While we can't travel to these parallel branches, their existence would mean that every moment of history is preserved somewhere in the larger multiverse. Every decision that could have been made was made somewhere. Every possible version of the past exists eternally in its own branch of reality. Even within our single branch of reality, quantum mechanics might preserve information from the past in subtle ways. The quantum vacuum, what we think of as empty space, is actually a seething foam of virtual particles constantly appearing and disappearing. These quantum fluctuations might carry information, encoding in their statistical patterns the history of everything that has happened in that region of space. It would be like the universe keeping a quantum diary, written in fluctuations too small and rapid for us to read with current technology, but perhaps accessible to sufficiently advanced observations. Every event would leave its mark on the quantum vacuum, creating a kind of holographic record distributed throughout space itself. Black holes present another intriguing possibility for preserving and possibly accessing the past. When matter falls into a black hole, it appears to slow down and freeze at the event horizon from the perspective of outside observers, though from the falling matter's perspective it passes through normally. This means that the entire history of everything that has ever fallen into a black hole is, in some sense, still visible at its event horizon, frozen in time like insects in amber. The information is scrambled and redshifted to the point of being unrecognizable, but according to quantum mechanics, information cannot be destroyed. Some physicists propose that this information is encoded on the black hole's surface in a holographic manner, two-dimensional information that describes three-dimensional events. What if we could learn to read this holographic information? What if the surface of every black hole is actually a vast library containing the complete history of everything that has fallen into it? Supermassive black holes at the centers of galaxies would be particularly rich archives, having swallowed stars, planets, and gas clouds over billions of years. The black hole at the center of our own galaxy might contain information about the early Milky Way, about stars and worlds that existed billions of years before our sun formed. Reading this information would require understanding physics at the intersection of quantum mechanics and general relativity, something we're still struggling to achieve, but the information might be there, waiting for us to develop the ability to decode it. Time crystals, a phase of matter discovered recently, show that structures can exist that repeat in time rather than space. Just as a regular crystal has a pattern that repeats in three-dimensional space, a time crystal has a pattern that repeats in time, oscillating forever without requiring energy input. This suggests that time might have structural properties we're only beginning to understand. Perhaps there are more complex temporal structures in the universe, patterns in time that preserve and repeat information from the past. These wouldn't be pathways to travel to the past, but ways that the past might echo into the present, creating recurring patterns that carry historical information forward through time. The expansion of space itself might offer ways to observe the deep past. As the universe expands, it stretches the wavelength of light, redshifting it toward longer, lower energy wavelengths. Light that was once visible becomes infrared, infrared becomes microwave, microwave becomes radio. In principle, if we could detect and decode extremely long wavelength radiation, we might be able to observe light from events so distant and ancient that their light has been stretched beyond what we currently consider the electromagnetic spectrum. There might be information from the very early universe, or from events we can't currently observe, encoded in wavelengths so long that we haven't built detectors capable of receiving them. Cosmic strings, if they exist, would be one-dimensional defects in space-time, incredibly thin but potentially stretching across the entire universe. These hypothetical objects would have enormous mass concentrated in a line thinner than an atom, warping space-time around them in unique ways. Two cosmic strings moving past each other at high speed could theoretically create closed time-like curves, paths through space-time that loop back to their own past. While we have no evidence that cosmic strings exist, they are predicted by some theories of the early universe. If they do exist, they might create regions of space where time behaves strangely, where the past is more accessible than elsewhere. But perhaps we don't need exotic physics to access the past. Perhaps the past is always with us, encoded in the present in ways we're only beginning to appreciate. Every atom in your body carries information about its history and its nuclear structure, its electron configuration, its quantum state. Every pattern in nature, from the spiral of galaxies to the branching of trees, carries information about the processes that created it. Every fossil, every rock layer, every ring in a tree trunk is a message from the past. We are surrounded by the past, immersed in it, made of it. Learning to read these messages more deeply might be a more practical form of time travel than building machines to physically journey to yesterday. Consider how much our ability to observe the past has improved with technology. Telescopes let us see billions of years into the past. Microscopes let us see fossils and structures invisible to the naked eye. Particle accelerators recreate conditions from fractions of a second after the Big Bang. DNA sequencing lets us read genetic history going back billions of years. Computer simulations let us model the evolution of the universe, galaxies, stars, and planets. Each advance in technology is really an advance in our ability to observe and understand the past. Perhaps future technologies will allow even more direct observations, ways of extracting historical information from the present that we can't yet imagine. Virtual reality and advanced simulations offer another kind of visit to the past. As our computational power increases and our understanding of history improves, we can create increasingly accurate reconstructions of past events and environments. These aren't the actual past, of course, but they might become so detailed and accurate that the experience of them becomes indistinguishable from visiting the real past. Imagine walking through ancient Rome, reconstructed down to individual stones and people, based on archaeological evidence, historical records, and scientific understanding of everything from weather patterns to social behaviours. It would be a kind of consensual illusion, a shared dream of the past, but it might satisfy much of our desire to visit yesterday. The holographic principle, a concept from theoretical physics, suggests that all the information in a volume of space can be encoded on the boundary of that space, like how a hologram encodes three-dimensional information on a two-dimensional surface. If this principle applies to the universe as a whole, then all the information about the interior of the universe, including its entire history, might be encoded on its boundary. We don't know what the boundary of the universe might be, or even if it has one in any conventional sense. But if the holographic principle is correct, then the information of the past isn't lost, but is encoded in the present structure of space itself, waiting to be decoded by sufficiently advanced understanding. As we imagine these possibilities, it's important to remember that we're not making scientific claims, but exploring the boundaries of what physics suggests might be possible. Most of these ideas are highly speculative, and some might turn out to be impossible for reasons we don't yet understand. But the fact that serious physicists can even discuss such possibilities shows how much stranger and more wonderful the universe is than our everyday experience suggests. Time might not be the simple, one-way street we experience it as. The past might not be as gone as we think. The universe might preserve its history in ways we're only beginning to glimpse. What's certain is that the universe does preserve information from the past in multiple ways we can already observe. Light from distant stars brings us images from years, centuries, or billions of years ago. Gravitational waves carry information about ancient collisions. The cosmic microwave background shows us the baby universe. Fossils preserve ancient life. DNA encodes evolutionary history. Rocks record geological events. Ice cores trap ancient atmospheres. Tree rings chronicle climate. The past is all around us, encoded in countless ways, waiting to be read and understood. Perhaps the real journey to the past isn't about building time machines or finding wormholes, but about learning to see the past that's already here, already accessible, already surrounding us. Every photon from a star, every atom in your body, every pattern in nature is a messenger from the past. We are already time travelers in the sense that we are constantly receiving information from the past and sending information to the future. We exist at the intersection of past and future, the only point where they meet, the eternal now that is always becoming then. As you lie there in the darkness, you are already on a journey through time, moving into the future at the steady rate of 1 second per second, while surrounded by signals from the past arriving at the speed of light, the speed of sound, the speed of chemical diffusion, the speed of memory. You are a nexus where different times meet and interact, where the past influences the present, and the present creates the future. You don't need a time machine to visit the past. You carry it with you in every atom of your being, in every memory in your mind, in every photon that reaches your eyes from distant stars. Think of all the lives that have unfolded before yours, like lanterns glowing briefly along a dark, quiet path, each one illuminating a small circle of experience before fading into the vast darkness of time. Every human who has ever lived, from our earliest ancestors emerging in Africa to this very moment as you listen to these words, has experienced the same fundamental flow of time that you experience. They've watched the same sun rise and set, though from different places on Earth. They've seen the same moon wax and wane, though they've told different stories about its patterns. They've felt the same progression from youth to age, the same sense of moments passing, accumulating into days, years, lifetimes. And if the past still exists in some form, if our exploration of space-time and light and matter has shown us anything, it's that their lives, their moments, their experiences might not be as lost as we typically imagine. Humanity's story begins in Africa, perhaps 300,000 years ago, though the exact timing and location remain subjects of ongoing discovery and debate. Our species, Homo sapiens, emerged from earlier human ancestors through a process of evolution that itself stretches back millions of years. But let's focus on our own species, on the remarkable journey that has taken us from a small population of hunter-gatherers in Africa to a global civilization capable of contemplating its own cosmic origins. Each step of this journey has left traces, not just in fossils and artifacts, but in the very structure of space-time, in light that continues to travel outward, in atoms that remember their configurations, in DNA that encodes our history. For most of our species' existence, perhaps 290,000 of our 300,000 years, we lived in small bands, probably no more than 150 individuals in most groups, hunting and gathering, following the seasons and the herds, learning the rhythms of the natural world. These weren't primitive people in any meaningful sense. They had the same cognitive capabilities we have, the same capacity for language, art, music, storytelling, love and wonder. They just lived in a different context, with different tools, different challenges, different ways of understanding their place in the universe. When they looked at the night sky, they saw the same stars we see, though without light pollution, they saw them far more clearly. They named the constellations, traced the movements of planets, used the stars for navigation and timing. Their observations and stories became the foundation of astronomy, humanity's oldest science. If the past persists in the ways we've been exploring, then somewhere in space-time, these ancestors still exist. The firelight from their evening gatherings is still travelling outward through space, carrying images of faces gathered around flames, of stories being told, of children learning, of adults planning, of elders remembering. Every word they spoke sent sound waves through the air, and while those sounds dissipated long ago in any conventional sense, the information they carried influenced everything around them in subtle ways that ripple forward through time. The atoms in the smoke from their fires are still on Earth, incorporated into soil, plants, animals, perhaps even into you. You might be breathing molecules that once passed through the lungs of these distant ancestors, a physical connection across hundreds of thousands of years. About 70,000 years ago, something remarkable happened. Humans began to spread out of Africa in a migration that would eventually take us to every continent except Antarctica. This wasn't the first time human species had left Africa. Homo erectus had done it more than 1 million years earlier, but this migration of Homo sapiens would eventually populate the entire planet. As we spread, we encountered other human species, Neanderthals in Europe and Western Asia, Denisovans in Asia, perhaps others we haven't yet discovered. We didn't just replace these other humans, we interbred with them. Most people today carry DNA from these other human species, genetic memories of encounters that happened tens of thousands of years ago. These migrations and meetings are preserved in multiple ways. Our DNA tells the story through genetic markers that track the movement of populations. Archaeological sites preserve tools, art, and remains that mark humanity's passage. Climate records in ice cores and ocean sediments tell us about the world these migrants encountered. Ice ages and warm periods, changing sea levels that created and destroyed land bridges, volcanic eruptions and asteroid impacts that influenced human movement and survival. Each migrating group left a trail of information across space and time, modifications to landscapes, extinctions of megafauna that coincided with human arrival, cave paintings and carved figurines that speak across millennia. The development of language, whenever exactly it occurred, was perhaps the most significant event in human history. Language allowed us to share complex information, to coordinate activities, to pass knowledge from generation to generation to create culture. Every conversation that has ever occurred sent pressure waves through air or water, vibrations that influenced everything they touched in subtle ways. While we can't recover those ancient conversations directly, their effects persist. The languages we speak today evolved from earlier languages, which evolved from even earlier ones, in an unbroken chain of verbal communication stretching back to the first words. Every word you speak is connected to that first word through an unbroken sequence of speakers and listeners, teachers and learners. About 12,000 years ago, as the last ice age ended and the climate warmed, humans independently invented agriculture in multiple locations around the world. This transformation from hunting and gathering to farming was gradual, taking centuries or millennia, but it fundamentally changed our relationship with time. Instead of following seasonal resources, we began to create them, planting seeds and waiting for harvests, planning months and years ahead. We began to modify landscapes on a large scale, clearing forests, irrigating deserts, terracing hillsides. These modifications are still visible today, not just in currently farmed areas, but in soil compositions, in the distribution of plant species, in the very genetics of our crops and livestock. With agriculture came settlements, then villages, then cities. Çatalhöyük in Turkey, one of the earliest known cities, was inhabited 9,000 years ago. Uruk in Mesopotamia grew to perhaps 50,000 people by 5,000 years ago. These early cities were experiments in human organization, creating new ways of living together, new social structures, new problems and solutions. The ruins of these cities preserve moments from daily life. Fingerprints in clay bricks, footprints in ancient streets, the remains of meals, toys children played with, art that decorated walls. But beyond the physical remains, if space-time preserves information as physics suggests, then the life of these cities, the sounds of markets, the conversations in homes, the celebrations and sorrows, all still exist somewhere in the four-dimensional structure of spacetime. Writing appeared about 5,000 years ago, first in Mesopotamia, then independently in Egypt, China, and Mesoamerica. With writing, humans gained the ability to preserve thoughts across time with unprecedented fidelity. The Epic of Gilgamesh, tax records from ancient Sumeria, love poems from Egypt, philosophical texts from Greece, all still speak to us today, voices from the past that remain audible through the technology of written symbols. Every text ever written, even those now lost, sent photons bouncing off its surface, light that carries information about those words into space. Somewhere light years away, those photons still travel, carrying libraries of ancient knowledge outward at the speed of light. The great ancient civilizations, Egypt, Mesopotamia, the Indus Valley, China, Mesoamerica, each developed their own ways of understanding and organizing time. They created calendars, tracked astronomical cycles, recorded historical events. The Egyptians aligned their pyramids with cardinal directions and stellar positions, encoding astronomical knowledge in stone. The Maya developed a complex calendar system that tracked multiple cycles of time simultaneously. Chinese astronomers recorded supernovae, solar eclipses, and comet appearances for thousands of years, creating an astronomical record that modern scientists still use. These civilizations were deeply concerned with time, with preserving knowledge for the future, with understanding their place in history. The classical civilizations of Greece and Rome gave us much of the intellectual framework we still use today. Greek philosophers contemplated the nature of time, with Heraclitus arguing that everything flows, and Parmenides arguing that change is an illusion. Aristotle defined time as the measure of change, while Plato suggested time was a moving image of eternity. Roman engineers built structures that have lasted 2 millennia, demonstrating that humans could create things that persist across vast spans of time. The roads they built still underlie modern highways, the aqueducts they constructed still carry water, the ideas they developed about law, governance, and citizenship still influence modern societies. The rise and spread of major religions added new dimensions to humanity's relationship with time. Buddhism, emerging in India 2,500 years ago, introduced concepts of cyclical time and rebirth. Judaism, Christianity, and Islam brought ideas of linear time with beginning and end, creation and judgment. These religious frameworks influenced how billions of people have understood their place in time, their relationship to the past and future, their sense of meaning and purpose. Every prayer ever spoken, every religious ritual ever performed, has sent ripples through space-time that, according to physics, never completely disappear but continue outward, gradually weakening but never reaching zero. The Middle Ages, often mischaracterized as a period of stagnation, saw remarkable developments in humanity's understanding and measurement of time. Mechanical clocks, invented in European monasteries, began to regularize daily life in ways that sundials and water clocks never could. Islamic scholars preserved and expanded upon Greek and Roman knowledge, developing algebra, advancing astronomy, creating precise calendars. Chinese inventors created printing, gunpowder, and the compass, technologies that would transform human civilization. Each innovation changed how humans experienced and related to time, creating new possibilities for preserving and transmitting information across temporal distances. The Renaissance and scientific revolution transformed humanity's understanding of our place in time and space. Copernicus moved Earth from the center of the universe. Galileo saw moons orbiting Jupiter. Kepler discovered the laws of planetary motion. Newton unified terrestrial and celestial physics. Suddenly, humans realized we lived in a universe far larger and older than previously imagined. Geological discoveries began to suggest Earth was not thousands but millions of years old. Fossil discoveries revealed that life had changed dramatically over time. Humanity began to see itself as part of a vast temporal process, rather than a special creation separate from nature. The Industrial Revolution, beginning in the 18th century, changed humanity's relationship with time in profound ways. Steam engines and factories regularized work schedules. Railroads required standardized time zones. Telegraph and eventually telephone allowed near-instantaneous communication across vast distances. Photography captured moments in time with unprecedented fidelity. These technologies didn't just change how we lived, they changed how we thought about time, making us more aware of its passage, more concerned with efficiency, more capable of preserving memories. Every photograph ever taken captured photons from a specific moment, preserving that configuration of light and matter. Even if the photograph is lost, those photons continued outward into space, carrying that moment's image into the cosmos. The 20th century brought revelations that fundamentally altered our understanding of time. Einstein's relativity showed that time is not absolute but relative, that simultaneity depends on your reference frame, that time and space are aspects of a single entity called spacetime. Quantum mechanics revealed that at the smallest scales, nature is probabilistic rather than deterministic, that the future is not entirely determined by the past. The discovery of the expanding universe showed that cosmos has a history, a beginning, possibly an end. The development of nuclear weapons showed that humanity had gained the power to influence its own future survival, to potentially end the human story that had been unfolding for 300,000 years. The space age, beginning in 1957 with Sputnik, gave humanity a new perspective on our place in time. The famous Earthrise photograph from Apollo 8 showed Earth as a small, beautiful, fragile world floating in the darkness of space. The Voyager spacecraft, launched in 1977, carry golden records with sounds and images from Earth, messages intended for any intelligent life that might find them millions of years from now. These spacecraft are humanity's first artifacts to leave the solar system, carrying information about our species into interstellar space, where it might survive long after Earth itself is gone. They are our attempt to make some part of human existence permanent, to ensure that something of our story persists into the deep future. The digital age has transformed how humanity creates, stores, and shares information across time. The internet connects billions of people in a global conversation that unfolds in real time. Social media preserves billions of moments from ordinary lives, creating a detailed record of daily human experience that would have been unimaginable to previous generations. Digital storage allows us to preserve vast amounts of information in tiny spaces. But digital information is also fragile, dependent on technology to read it, vulnerable to degradation and obsolescence. We can store more information than ever before, but we're also at risk of losing more information than ever before if our technological infrastructure fails. Climate change represents humanity's most significant impact on Earth's future history. We are altering the atmosphere, oceans, and biosphere in ways that will persist for thousands or millions of years. The carbon dioxide we're adding to the atmosphere will influence climate for millennia. The species extinctions we're causing will leave gaps in the fossil record that future paleontologists will puzzle over. The plastics we're creating will form a geological layer marking our era. We're writing our chapter in Earth's history, though we're still determining what story it will tell. Our actions today create the past that future generations will inherit and study. As we contemplate humanity's place in the river of time, it's worth considering what makes us unique among Earth's species. We are not the strongest, fastest, or most numerous, but we are, as far as we know, the only species capable of contemplating deep time, of understanding our cosmic origins, of deliberately sending messages to the future. We are the only species that creates art intended to last, that builds monuments to memory, that writes histories and imagines futures. We are time-binding animals, connecting past to future through culture, technology, and conscious intention. Every human life adds to this accumulating story. Your life, however ordinary it might seem, is part of humanity's journey through time. Every choice you make, every word you speak, every action you take sends ripples through space-time that influence the future in ways small and large. If the past persists in the ways physics suggests, then your life is not temporary but permanent, a thread in the vast tapestry of human existence that will always exist in the four-dimensional structure of space-time. Your ancestors' lives are not gone but are elsewhere in space-time, and your life will similarly persist, always part of the universe's eternal structure. Consider the remarkable fact that you can understand these ideas, a collection of atoms that originated in the Big Bang and were processed through stellar nuclear furnaces, has organized itself into a pattern capable of contemplating its own origins and destiny. You are the universe, becoming aware of itself, able to look back across billions of years and understand, at least partially, how you came to be. You can look forward and imagine possible futures, making choices that influence which possibilities become realities. You exist at a unique moment in cosmic history, when the universe has become complex enough to study itself, to remember its past, to plan its future. The human story is still being written. We don't know how long our species will survive, whether we'll spread to other planets, whether we'll transcend our biological origins through technology, whether we'll make contact with other intelligent life. But whatever happens, the part of the story that has already unfolded the 300,000 years of human existence so far is permanent in the sense that it has happened and, if physics is correct, exists eternally in space-time. Every human who has ever lived has added their thread to this tapestry. Every moment of joy, sorrow, discovery and confusion has become part of the permanent structure of reality. As you lie there in the darkness, you are connected to every human who has ever lived through chains of cause and effect, through shared atoms, through cultural transmission, through DNA, through the simple fact of being human. You breathe air that has been breathed by billions before you. You think with a brain shaped by millions of years of evolution. You speak languages that evolved from the first words. You're not separate from human history, but are its current expression, its living edge, the point where past becomes future. In you, 300,000 years of human experience continues its journey through time. We began by asking if the past might still exist somewhere, waiting for us like a distant, remembered shore. And now, as the night deepens around you and your thoughts grow softer and slower, we return to this question with new understanding. Through our journey tonight, we've seen that the past does indeed persist in countless ways. In light still traveling through space, in the structure of space-time itself, in gravitational waves rippling outward from ancient collisions, in atoms that remember their cosmic history, in DNA that encodes billions of years of evolution, in rocks that preserve Earth's story, in the very fabric of reality that physics suggests might be eternal and unchanging, with all moments existing simultaneously in a four-dimensional block. But perhaps the most profound place where the past lives is within you, right here, right now, in this very moment of awareness. You're not separate from the past, but are made of it, shaped by it, carrying it forward in every atom of your being, every pattern of your thoughts, every rhythm of your breath. The calcium in your bones was forged in the heart of a dying star billions of years ago, and has been part of countless structures since then. Interstellar dust, asteroids, mountains, seas, other living beings, and now, temporarily, you. That calcium remembers, in the unchanging structure of its atomic nucleus, the unimaginable temperatures and pressures of stellar nuclear fusion. It carries the past within it, not as memory in any conscious sense, but as physical reality, as patterns that persist across eons. Your DNA is a library of the past, encoding not just the instructions for building your body, but the history of how those instructions evolved. You share genes with every human who has ever lived, genes that have been copied and passed down through thousands of generations, each copy preserving information from the deep past. You share older genes with all mammals, even older genes with all animals, ancient genes with all life on Earth. Some of your genes are virtually identical to genes in bacteria, unchanged after billions of years of evolution. When your cells divide and copy your DNA, they're performing a ritual that has been repeated countless trillions of times since life began. Each repetition, a link in an unbroken chain connecting you to the first living cell. Your brain carries the past in its very structure. The oldest parts of your brain, the brainstem that controls breathing and heartbeat, evolved hundreds of millions of years ago. The limbic system that generates emotions evolved with early mammals. The neocortex that enables complex thought is more recent, but still ancient by human standards. These different layers of brain evolution don't replace each other, but build upon each other, so you carry within your skull a museum of neurological evolution, different eras of development still functioning together. When you feel fear, you're using neural circuits that protected your ancestors from predators millions of years ago. When you feel love, you're activating systems that evolved to bond parents to offspring, ensuring survival across generations. Memory itself is a form of time travel, a way the past lives within the present. When you remember something, your brain recreates patterns of neural activity similar to those that occurred during the original experience. You're not retrieving a stored file, but reconstructing the past from traces it left in your neural networks. Each memory is both a preservation of the past and a creation in the present, influenced by everything that has happened since the original event. Your memories are not perfect recordings, but living, changing echoes of experiences that, if space-time is as physics suggests, still exist in their original form elsewhere in the four-dimensional structure of reality. Language carries the past forward in the words you speak and think. Every word has a history, evolving from earlier words in ancestral languages, carrying meanings that have shifted and accumulated over centuries or millennia. When you say mother, you're using a word that connects to the Proto-Indo-European mester spoken 6,000 years ago, which connects to even earlier words in languages lost to history. The grammar you use, the way you structure sentences, reflects patterns that evolved over thousands of years of human communication. Even new words and phrases build on old foundations, remixing ancient elements in novel combinations. Culture is another way the past lives within us. The stories we tell, the songs we sing, the rituals we perform, many have roots stretching back generations, centuries, or millennia. Fairy tales told to children today contain elements from prehistoric oral traditions. Holiday celebrations incorporate customs from multiple historical periods, layered like geological strata. The way we prepare food, build houses, form relationships, raise children, all are influenced by cultural patterns passed down through time, each generation adding variations while preserving core elements. You're not just an individual, but a bearer of culture, carrying forward patterns that began long before you were born and will continue long after you're gone. Your emotions connect you to the deep past of not just humanity but life itself. Fear, love, anger, joy, sadness. These are not modern inventions but ancient patterns that have been refined by evolution over millions of years. When you feel protective of children, you're experiencing an emotion that has been preserving young lives since the evolution of parental care. When you feel pleasure from eating sweet foods, you're responding to programming that helped your ancestors identify ripe fruits and other sources of energy. When you feel lonely, you're experiencing the social bonding mechanisms that kept our ancestors together in groups, enhancing survival through cooperation. These emotions are the past living within you, ancient wisdom encoded in feelings rather than thoughts. Even your consciousness itself might be a way the past persists into the present. Some theories suggest that consciousness is fundamental to the universe, not emerging from complex arrangements of matter, but existing as a basic feature of reality like mass or charge. If this is true, then consciousness might be eternal, experiencing different moments sequentially but existing across all time. Your experience of being aware, of having subjective experience, might connect you to a fundamental aspect of reality that has existed since the universe began. You might be not just a temporary arrangement of matter that happens to be conscious, but a permanent feature of space-time experiencing itself from a particular perspective. The rhythm of your breathing connects you to cycles that have been repeating since life first evolved. Inhale, exhale, the exchange of oxygen and carbon dioxide, this process has been happening in various forms for billions of years. The oxygen you breathe was produced by photosynthesis, a process invented by cyanobacteria billions of years ago. The carbon dioxide you exhale will be absorbed by plants, continuing the cycle. Each breath connects you to the global respiratory system of Earth, to every plant and animal, to the cycling of gases that maintains our atmosphere's composition. You're not breathing alone, but participating in a planetary process that has been ongoing since life began transforming Earth's atmosphere. Your circadian rhythms, the daily cycles of waking and sleeping, connect you to the rotation of Earth, to the alternation of day and night that has been occurring for 4.5 billion years. These rhythms are encoded in your genes, synchronized by light but persisting even in constant darkness. Almost every cell in your body has its own molecular clock, cycling through patterns of gene expression that repeat approximately every 24 hours. These cellular clocks evolved to anticipate the daily changes in environment, preparing your body for activity during day and rest at night. When you feel sleepy as darkness falls, you're responding to ancient programming that predates humanity, that evolved when our ancestors first developed the ability to detect and respond to light. Sleep itself is a journey through different states of consciousness that connect you to the evolutionary history of rest and restoration. The stages of sleep you cycle through each night, from light sleep to deep sleep to REM sleep, each serve different functions that evolved over millions of years. Deep sleep seems to be the most ancient, present in some form in all animals, serving basic functions of physical restoration and memory consolidation. REM sleep, with its vivid dreams and paralyzed body, might have evolved more recently, perhaps playing roles in emotional processing and creativity. When you dream, you enter a state where time behaves strangely, where past, present, and future mix freely, where the impossible becomes possible. Dreams might be windows into how consciousness experiences time when freed from the constraints of waking attention. As you prepare to sleep tonight, consider that sleep itself is a kind of time travel. You close your eyes in one moment and open them hours later, having jumped across time with little awareness of its passage. Your body has continued its processes, your brain has consolidated memories and cleared metabolic waste. The Earth has rotated, carrying you thousands of miles through space, yet you experienced little of this journey. Sleep is a reminder that our experience of time is constructed by consciousness, that time can seem to stop or jump or flow at different rates, depending on our state of awareness. The question we began with, whether the past still exists somewhere you could visit, has revealed itself to have multiple answers, each true in its own way. Yes, the past exists in light still travelling through space, carrying images of every moment that has ever been illuminated. Yes, the past exists in the structure of space-time, if physics is correct that all moments exist eternally in the four-dimensional block universe. Yes, the past exists in gravitational waves and cosmic microwave background radiation, in the distribution of galaxies and the chemistry of stars. Yes, the past exists in rocks and fossils, in ice cores and tree rings, in the arrangement of continents and the composition of the atmosphere. But most immediately, most intimately, the past exists within you. You're not separate from history, but are made of it, shaped by it, carrying it forward with every breath, every heartbeat, every thought. You're a collection of atoms with cosmic histories, arranged in patterns refined by billions of years of evolution, conscious through processes we don't fully understand but that connect us to the deepest mysteries of existence. You are a way for the universe to remember itself, to experience its own history subjectively, to connect past and future through the bridge of conscious awareness. As your thoughts grow quieter and slower, as you drift toward the edge of sleep, you can rest in the knowledge that nothing is ever truly lost. If the universe is as physics suggests, a four-dimensional structure where all moments exist eternally, then every moment of your life, every person you've loved, every experience you've had, remains forever part of the cosmic tapestry. Death is not erasure, but simply the boundary of your world line in space-time. The past is not gone, but is elsewhere in the eternal structure of existence. The future is not yet to be created, but might already exist, waiting for your consciousness to experience it moment by moment. This view might seem to remove meaning from life. If everything already exists, if past and future are fixed features of space-time, what's the point of choosing, of striving, of living? But perhaps it's the opposite. If every moment is eternal, then everything matters. Every kindness, every cruelty, every moment of beauty or suffering becomes a permanent part of reality. Your choices don't just affect the future, they determine what has always existed in the eternal structure of space-time. You're not just passing through time, but creating it. Or rather, you are the process by which the eternal structure of space-time becomes experienced, becomes real in the subjective sense that might be the only sense that matters. The universe is vast and old and will continue long after Earth and Sun have ended. But you are here now, or rather you are here now, a unique point in space-time where the universe becomes aware of itself. Through your eyes, the cosmos sees. Through your thoughts, it contemplates. Through your emotions, it feels. You're not small and insignificant, but are the very purpose of existence, if existence has a purpose, to be experienced, to be known, to be felt from the inside rather than just described from the outside. As sleep approaches, you can let go of the need to understand everything, to solve the mystery of time. The question itself is enough, the wondering is enough, the gentle contemplation of possibilities is enough. Whether the past exists as physics suggests, or whether it's truly gone, whether the future already exists or is yet to be determined, whether consciousness creates time or time creates consciousness, these are questions that may never have final answers. But the asking of them, the capacity to wonder about them, the ability to contemplate our own existence and its temporal nature, this is the miracle. You exist at the intersection of eternity and moment, of cosmos and consciousness, of past and future. You are made of ancient stardust contemplating the stars. You carry billions of years of history in your atoms and genes while creating new moments that have never existed before. You are both the reader and the writer of time's story, both the observer and the observed, both the question and part of the answer. Let your breathing slow and deepen. Feel the gentle rhythm that connects you to all life, to the cycling of gases that has maintained Earth's atmosphere for billions of years. Let your thoughts settle like sediment in still water, each one finding its place in the quiet depths of mind. You don't need to hold on to anything. The universe holds it all for you, preserving every moment in light and space-time, in atoms and energy, in the vast memory of existence itself. The past lives within you, not as burden, but as foundation. The future exists around you, not as pressure, but as possibility. And the present, this eternal now that is always slipping into then, is where you always are, always have been, always will be. You are home in the river of time, not drowning but floating, not lost but exactly where you need to be, part of something infinitely larger than yourself yet intimately, immediately present in this moment of awareness. As you drift towards sleep, wrapped in darkness and silence, you can feel yourself as part of the vast cosmic story, a story that began with the Big Bang and continues through you into an unknown but not unknowable future. Every atom in your body has travelled for billions of years to be here now. Every ancestor in your lineage survived and reproduced to make your existence possible. Every moment of cosmic evolution has led to this moment of you lying here, conscious, aware, wondering about time and existence. You are the universe's gift to itself, a point of awareness in the vast unconscious cosmos, a way for existence to experience what it feels like to exist. And as you fall asleep, you don't disappear, but simply transition to a different state of being, one where time flows differently, where dreams mix past and future, where the impossible becomes possible. Sleep is not an ending, but a transformation, not a loss of consciousness, but a different kind of consciousness, one that has its own wisdom, its own way of processing time and memory. The night is deep around you now, and the journey we've taken together through time and space, through physics and philosophy, through cosmic history and personal existence, comes not to an end but to a pause. The questions remain open, the mysteries remain mysterious, the wonder remains wonderful. And that's as it should be. A universe that could be fully understood would be smaller than the mind understanding it. A reality that could be completely explained would be less than the consciousness explaining it. So rest now in not knowing, in wondering, in being part of something vast and beautiful and strange. Rest in the knowledge that you are made of time and space, of matter and energy, of past and future meeting in the eternal now of your awareness. Rest in the fact that nothing is ever truly lost, that the past lives on in countless ways, that you are surrounded by and made of deep history, even as you create new moments that add to the cosmic story. The past still exists, somewhere, somehow, in light and space-time, in atoms and memory, in the very fact that you are here now, product of all that has come before, seed of all that will come after. You don't need to visit the past. You are the past, transformed and transforming, ancient stardust dreaming it is human, temporary pattern in the eternal dance of existence. Sleep now, and let time carry you gently into tomorrow, knowing that today will never be lost but will join the vast archive of moments that make up the history of the universe. Your story continues even in sleep, your atoms continuing their ancient journeys, your cells maintaining their processes, your brain consolidating memories and generating dreams, your consciousness exploring states of being that connect you to the deepest mysteries of time and existence. And when you wake, you will wake not just from sleep, but into a new moment of the cosmic story, a moment that has never existed before yet is connected to everything that has. You will wake as the universe waking to itself, ancient and new, permanent and transient, a paradox of time that doesn't need to be resolved but simply experienced, simply lived, simply breathed into being moment by moment by moment. The past lives within us, the future surrounds us, the present is where we always are, and in this eternal now, in this moment that is all moments, in this place that is all places, you can rest, you can sleep, you can dream. knowing that you are exactly where and when you need to be, part of the vast cosmic story that has no beginning and no end but simply is, always and forever, world without end, time without termination, existence without erasure. Good night, fellow traveller through time. May your dreams carry you gently through the hours of darkness, and may you wake refreshed, ready to add new moments to the eternal tapestry of existence, knowing that nothing is ever lost, that the past lives on, that you are home in the river of time.